Hello everyone and welcome back. This is Ahmad again for Avionics, and this is the scripting languages mini course. In this mini course, we are going to cover the basic scripting languages that any DevOps engineer should have under his or her belt. We are going to start with the Bash scripting language, which is the shell language used in Linux. You will have to be very proficient using the Bash shell if you are going to seek the DevOps career. The second language in our list is Python, which is of course a very efficient and powerful scripting language. It can be used to perform the simplest tasks up till the most complex ones. It has established itself as a solid scripting language, and of course a DevOps engineer should be proficient using Python. The last language in our list will be Ruby. Ruby is a fairly new language if it is compared with other ones like Python or Perl, and yet it has been widely adopted among sysadmins. It is also used in many of the DevOps tools that we are going to cover throughout this program, like Vagrant, Chef, and Puppet. I hope you're going to enjoy watching this mini course, and see you in section 1.
Hello everyone and welcome back. This is Ahmad again for Avionics, and this is the second course in our DevOps e-degree program. In this course, we are going to study scripting. I like to refer to scripting as the DevOps engineer's tool belt. In a scripting language, you are focused on speed of writing code and getting the job done more than on code optimization, memory management, resource consumption, and other aspects of modern higher-level programming languages like Java, C#, and other programming languages. That's why it's not the best idea to use Java, for example, for renaming a bunch of files in a directory. A scripting language is the better candidate for such a job. In this course, I chose 3 of the most widely used scripting languages to explore. We are going to cover Bash, because Bash is the default shell for almost all Linux and Unix distributions. Then we are going to cover some Python code. Python is a well-established, powerful language that can be used for both scripting and writing fully-fledged programs. We are going to end this course by a brief introduction to Ruby. Ruby is also a very powerful scripting language, and it is often regarded as a successor for Perl, the very famous scripting language Perl, which was the dominant scripting language since the 1980s, and actually it is still being used till this day. But Ruby offers more features, it is more elegant, and it is more widely used nowadays. It is also used in some of the DevOps tools that we are going to cover later in this program, like Vagrant and Chef and Puppet. So let's get started. If we want to talk about the Bash shell, let's see what the name refers to. Bash is short for Born Again Shell. The Born shell is one of the oldest shells that was used in the Unix platform since 1979, and the Born Again shell is the successor or considered to be the enhanced version of the Born shell. So, how to start the shell? We are now in our directory in which we installed our Vagrant machine in the last lecture, in the last section where we deployed the Apache web server. Let's use Vagrant SSH to get inside the machine again. It's a CentOS machine, and okay, we need to run Vagrant up first to bring the machine up and running. And this machine, as you probably remember from last section, is running CentOS 7. So Bash is the default shell for CentOS and Ubuntu, and as we mentioned, other Linux distributions. Okay, so here we are inside. Let's return back to our question, how to start the shell. The shell gets started automatically when you log in to the system, because this is the initial program. The OS is programmed to start whenever somebody logs in using the CLI. So in our case, we have logged into this machine using the CLI or the command line interface. If you are using the GUI version of a Linux, like Ubuntu for example, or the GUI version of CentOS, you may have a program that is called a terminal. And the terminal will open a terminal emulator, a window just like this one, but inside the Linux box, and it will open a Bash shell for you. But technically, what happens when you log into the machine? What happens is that this program is executed /bin/bash, like this. When I typed in /bin/bash or simply bash, I am starting a new subshell inside the shell that I am already at. Bash is just a program. It is a binary program This binary program, its job is to provide this interactive interface for you. This screen where you can type commands like ls, for example, or pwd to display the current working directory, and you can also echo something to the screen, echo hello. What makes this possible is the program that is called bash and that resides by default in /bin directory. So when you type bash like this, you are actually opening a second instance or a child instance of the shell inside the shell where you are already running. So what's the difference, or why should you care whether you are on the main shell or on a subshell? That will be very obvious when we discuss variables. So let's discuss variables. A variable, as you probably know, is a container for data. So for example, if I want to store something and I want to refer to that later in my code, I store it in a variable. Variables in bash can be assigned as follows. So let's say I want to store my name like this. My name is or equals Ahmad. You start with the variable name, my name, followed by an equal sign, followed by the value that you want to assign to the variable. But notice here that bash, in contrast to other languages, it does not accept any spaces between the equal sign and the variable name, or between the equal sign and the value of the variable. If you try to add a space, it won't work. If I did it like this, this will simply not work. It will not accept the equal sign with a space before or after it. It will just consider that my name now is a command or a program that you need to invoke, and clearly do not have a program or a script or a binary file that is called my name in your current path. So it just fails with command not found. So if you want to assign a variable, remember not to add any spaces before or after the equal sign. Okay, back to our topic. Now, if I want to recall this variable or use it in my code, all what I have to do is precede the variable name with a $sign. So if I want to say my name, I can do it like this, echo, and echo is a command in bash that prints whatever comes after it to the screen. So I am now printing the value of my name, the variable that was called my name, to the screen, which is Ahmed. Now what happens if I open a subshell like this? Type bash, now you are in a new shell. Now try to echo my name again. As you can see, nothing, just a new line or an empty line. That is because variables are by default local to the shell where they were created. So if I created a variable inside my shell, if I open the subshell, this variable will no longer be available to me. If I exit from this shell by using the exit command like this, or by just typing Ctrl-D, now if I echo again my name, I'm going to see that I have my name back because I am returning back to the shell where this variable was defined. So what if you want to use this variable in the current shell and in all subshells? Simply, you can just use the export command like this. So I can use export my name. Remember not to add the $sign when you use the export command. Export is going to promote the variable from a local variable to a global variable, or sometimes referred to as an environment variable. An environment variable is a variable that exists or persists across multiple subshells. So if I use export followed by the variable name without the $sign like this, now if I open another bash shell and I try to echo my name again, I'm going to see that it is now available. Even if I opened another subshell, echo my name, it's available, a third subshell, you get the point, okay? And you can also notice here that I'm not using the exit command, I'm not typing it literally, I'm just typing Ctrl+D and it will automatically exit from the current shell. So this is a handy shortcut if you want to use it. And now I can also use the export command while I am creating the variable like this. Export my course equals DevOps like this. And it will work similarly. Now if I echo $sign my course, it's going to print DevOps although I am inside another shell. So that was a brief introduction to the bash shell and how to start the shell and how to use subshells. In the coming lecture, we are going to start writing commands on the bash shell and see how we can group them together. So until next lecture, take care. Hello everyone and welcome back. This is Ahmed again for Avionics, and this is the second course in our DevOps e-degree program. In this course we are going to study scripting. I like to refer to scripting as the DevOps engineer's tool belt. In a scripting language, you are focused on speed of writing code and getting the job done more than on code optimization, memory management, resource consumption, and other aspects of modern higher-level programming languages like Java, C#, and other programming languages. That's why it's not the best idea to use Java, for example, for renaming a bunch of files in a directory. A scripting language is the better candidate for such a job. In this course, I chose 3 of the most widely used scripting languages to explore. We are going to cover Bash, because Bash is the default shell for almost all Linux and Unix distributions. Then we are going to cover some Python code. Python is a well-established, powerful language that can be used for both scripting and writing fully fledged programs. We are going to end this course by a brief introduction to Ruby. Ruby is also a very powerful scripting language, and it is often regarded as a successor for Perl, the very famous scripting language Perl, which was the dominant scripting language since the 1980s, and actually it is still being used till this day. But Ruby offers more features, it is more elegant, and it is more widely used nowadays. It is also used in some of the DevOps tools that we are going to cover later in this program, like Vagrant and Chef and Puppet. So let's get started. If we want to talk about the Bash shell, let's see what the name refers to. Bash is short for Born Again Shell. The Born shell is one of the oldest shells that was used in the Unix platform since 1979, and the Born Again shell is the successor or considered to be the enhanced version of the Born shell. So, how to start the shell? We are now in our directory in which we installed our Vagrant machine in the last lecture, in the last section where we deployed the Apache web server. Let's use Vagrant SSH to get inside the machine again. It's a CentOS machine, and okay, we need to run Vagrant up first to bring the machine up and running. And this machine, as you probably remember from last section, is running CentOS 7. So Bash is the default shell for CentOS and Ubuntu, and as we mentioned, other Linux distributions. Okay, so here we are inside. Let's return back to our question, how to start the shell. The shell gets started automatically when you log in to the system because this is the initial program. The OS is programmed to start whenever somebody logs in using the CLI. So in our case, we have logged into this machine using the CLI or the command line interface. If you are using the GUI version of a Linux, like Ubuntu for example, or the GUI version of CentOS, you may have a program that is called a terminal. And the terminal will open a terminal emulator, a window just like this one, but inside the Linux box, and it will open a Bash shell for you. But technically, what happens when you log into the machine? What happens is that this program is executed /bin/bash, like this. When I type in /bin/bash or simply bash, I am starting a new subshell inside the shell that I am already at. Bash is just a program. It is a binary program. This binary program, its job is to provide this interactive interface for you. This screen, where you can type commands like ls, for example, or pwd to display the current working directory, and you can also echo something to the screen, echo hello. What makes this possible is the program that is called Bash and that resides by default in /bin directory. So when you type bash like this, you are actually opening a second instance or a child instance of the shell inside the shell where you are already running. So what's the difference, or why should you care whether you are on the main shell or on a subshell? That will be very obvious when we discuss variables. So let's discuss variables. A variable, as you probably know, is a container for data. So for example, if I want to store something and I want to refer to that later in my code, I store it in a variable. Variables in Bash can be assigned as follows. So let's say I want to store my name like this. My name is or equals Ahmed. You start with the variable name, my name, followed by an equal sign, followed by the value that you want to assign to the variable. But notice here that bash, in contrast to other languages, it does not accept any spaces between the equal sign and the variable name, or between the equal sign and the value of the variable. If you try to add a space, it won't work. If I did it like this will simply not work. It will not accept the equal sign with a space before or after it. It will just consider that my name now is a command or a program that you need to invoke, and clearly do not have a program or a script or a binary file that is called my name in your current path. So it just fails with command not found. So if you want to assign a variable, remember not to add any spaces before or after the equal sign. Okay, back to our topic. Now, if I want to recall this variable or use it in my code, all what I have to do is precede the variable name with a $sign. So if I want to say my name, I can do it like this, echo, and echo is a command in bash that prints whatever comes after it to the screen. So I am now printing the value of my name, the variable that was called my name, to the screen, which is Ahmed. Now what happens if I open a subshell like this? Type bash, now you are in a new shell. Now try to echo my name again. As you can see, nothing, just a new line or an empty line. That is because variables are by default local to the shell where they were created. So if I created a variable inside my shell, if I open the subshell, this variable will no longer be available to me. If I exit from this shell by using the exit command like this, or by just typing Ctrl D, now if I echo again my name, I'm gonna see that I have my name back because I am returning back to the shell where this variable was defined. So what if you want to use this variable in the current shell and in all subshells? Simply, you can just use the export command like this. So I can use export my name. Remember not to add the $sign when you use the export command. Export is going to promote the variable from a local variable to a global variable, or sometimes referred to as an environment variable. An environment variable is a variable that exists or persists across multiple subshells. So if I use export followed by the variable name without the $sign like this, now if I open another bash shell and I try to echo my name again, I'm going to see that it is now available. Even if I opened another subshell, echo my name, it's available, a third subshell, you get the point, okay? And you can also notice here that I'm not using the exit command, I'm not typing it literally, I'm just typing Ctrl+D and it will automatically exit from the current shell. So this is a handy shortcut if you want to use it. And now I can also use the export command while I am creating the variable like this. Export my course equals DevOps like this. And it will work similarly. Now if I echo $sign my course, it's going to print DevOps although I am inside another shell. So that was a brief introduction to the bash shell and how to start the shell and how to use subshells. In the coming lecture, we are going to start writing commands on the bash shell and see how we can group them together. So until next lecture, take care. Alright, hello everyone, welcome back. Of course, all of you know how to run commands on the bash shell. Let's clear the screen. Now, when I run echo my name, that is a command that I'm running it on the shell. Okay. However, some of the commands are built inside the shell, inside bash, while some other commands are just binary files that happen to be on your file system, and bash executes them for you. So, for example, the echo command is part of the bash shell itself. If you want to know, or if you want to make sure, just type man bash. Of course, I guess most of you know that the man command is short for manual, and it is used to display help on various commands. I'm using man against the bash command itself, or the binary of the shell itself. If I open it, I'm going to see that I have a lot of commands that are internal to the shell. Like here, the while loop, we're going to cover that later, the for loop, the case. Let's search for echo. Okay, echo. Here we go. Echo is part of the bash shell. Okay, and this is the help screen for echo, while some other commands are external, like for example the ls command. I guess it's inside /bin. Okay, /bin/ls, because this directory is empty. Let's add -a to display hidden files. Okay, the ls command is not part of the bash shell. The ls command, which will list or display the directories and files that are inside the current directory by default, or it will accept an argument or a number of arguments containing file paths. But bash has also the capability of executing shell scripts. A shell script is just a text file that contains a number of commands, and those commands get executed all at once. So let's use your favorite editor. Mine is VI. You can use Nano, you can use whatever text editor you want. And I'm going to create a file that is called naturally script.sh. I can write here echo. Let's just mimic what we have just did. Let's create a variable. Let's call it my var, and let that be shell scripting. Okay. And let's echo my var. Okay. Let's save. And now I have two options for running this script. I can either run it by using the bash binary and giving it the path to the file, which happens to be in the current directory. So I'm just going to run bash followed by script.sh, and it's going to create the variable, which is my var, and echo its contents, shell scripting. That is what the script does. Okay, as you can see, my var is shell scripting and echo $my var. But notice what happens here. When I wanted to execute this script, I had to use the bash binary. So this means that it is going to open a subshell for me, execute this script, and then return back to me. Why this is important? Because if you remember from last lecture, we said that variables by default are local to their current shell. So if I have a variable like this, var2, for example, is hello, for example, and I tried to reference this, inside this shell script, so let's delete it and let's echo var2. This simply won't work. And I guess you know why. That is because variables are local to their current shell. If I export this variable, we have covered that already, but I just want to apply it to shell scripts. If I export it var2, now I am able to, export should not be with a $sign. Now if I run the script again, it is going to print the value of var2, which is hello. Some people get confused because most of system administrators or bash users, they execute their shell scripts using the self-execution mechanism, like this, /script.sh, for example. But of course, to do this, you must give it the execute permissions first. So chmout +x script.sh, and optionally, you can add a shebang at the start of the file. This will just inform bash that this file is going to be executed using, well, bash. That is because by default Linux can have multiple shells. So you can have the bash shell, there are other types of shells like the corn shell, KSH, or the Z shell, ZSH, or the C shell, CSH, and others. So maybe you want this to be executed by another shell or another program. Maybe you have Python installed and you want to run this file as a Python script, not a bash script. So this line of code is going to inform bash about the kind of binary or the kind of program that will be used to parse and execute the contents of the file. In our case, we just want to stick to bash, so we are going to type shebang, or the hash followed by the exclamation mark, and the path to the executable of bash. So now if I execute this, which is how most system administrators, as I mentioned, are used to running shell scripts, it is going to give me the same result. But notice what happens here. It will also follow the same behavior as we did when we type bash script.sh. In other words, it is going to open a subshell, execute whatever was in that file, and then return back to your current shell. This is very important if you are using variables a lot, because you will have to remember to use export whenever you want your variable to be available to all the scripts that are running in your system, or not to use the export if you want to avoid name collision. So for example, you might have a variable that is called, for example, username. That is a real world example. And you set username, for example, to be Bob. And if you exported this username like this, and you happen to have a script that internally uses this username to grab some data or to perhaps connect to a database or do something, a name collision will inevitably happen. It's going to use the username that you have defined, or at least some confusion is going to happen because there will be two variables with the same variable name, but they are obviously holding different values. So make sure you understand the scope of variables, make sure you understand the role of the export command, when to use it and when not to use it. Okay, so this is how you run commands on your shell script, on your bash shell, how to group the commands inside a script file. Let's now have a look at some of the important files that the bash shell honors when it starts or when it works. First, we have the .bash_profile. This file may or may not exist in your home directory, but most probably you will find it. Let's see what is inside this file, .bash_profile. If you get inside, you're going to find that you have some important data. For example, here we have an if condition. We're going to cover if conditions later in this course. It is looking for a file that is called .bashrc. I'm going to tell you what bashrc is for in a moment. And if this file exists, it is going to execute it using the source command. Okay. And also it is setting your path. The path variable is where bash will look for the commands that you type on your command line and you don't type the full path for. So if I type ls, for example, it is going to automatically consult the path to see if this ls command resides in one of the predefined paths, one of which of course is /bin. So when it finds the ls command in /bin, it executes it without needing to have the full path. This is the role of the path variable. And as you can see, it exports the path variable so that it is available to you whenever you open a new subshell. Now, let's have a look at this statement, why it is using the .bashrc and why it is using this source command or dot to execute the bashrc. Okay. The .bash_profile gets executed whenever the login shell is invoked. Okay, so what is a login shell? The login shell, as the name suggests, is the shell that you have when you first log in to the system. It is the first shell that you invoke when you log into the system, or when you, for example, switch to another user. So if I switch it to root, for example, like this, let's use sudo, because I don't know the root password for this machine, so sudo su-. Now I am switching my user account to be root, and now I have opened a login shell for the root user. Let's exit. If I open a new shell like this, a new subshell, this is not a login shell. This is just a subshell, not the login shell. So .bash_profile will get executed whenever the login shell is invoked, but only when the login shell is invoked. If any subshell is invoked, the .bash_profile will not be invoked again, just once. On the other hand, the .bashrc is going to be invoked whenever a new subshell or a login shell is started. So it's going to be invoked in both cases, when the login shell is invoked or when any subshell is invoked. Let's see a proof for that. I'm going to create the .bashrc file. Okay, or it's already there, okay? And as you can see, it has the very same command that is inside the .bash_profile, which is to source /etc/bashrc, which is the skeleton or the source for the bashrc. It contains some environment level commands and variables that are needed for bash to function correctly. Now let's say that I will echo this is a new shell. Just echo this statement whenever a new shell is started, and let's exit from this current shell. And okay, let's exit from all the shells that we have started. Let's just exit from the system and go to vagrant SSH again, open a login shell. Okay, as you can see, this is a new shell, is printed to the screen. Let's clear the screen. And what if I want to open a new subshell? Again, this is a new shell. Whenever you open a new shell, this statement is always going to be printed for you. However, if I added this same statement to bash underscore profile, let's say echo, this is a login shell, it will only be displayed when I first log into the system. So if I exited from all the shells that I have opened and again type vagrant SSH to log in back to the machine, you're gonna find that, okay, this is a new shell because .bash rc gets executed first, because that is the instruction or the command that is added to the .bash underscore profile to execute the .bash rc whenever it is present. Then the content of the .bash underscore profile itself is executed, which is this is a login shell. But if I open a new shell, okay, this is just a new shell. This is a login shell, is no longer displayed because .bash rc is the only file that gets executed when a subshell is opened. Okay, what about the source command? Let's have a look again at .bash underscore profile. And let's have a look at this dot. This dot is short for source, or it is an alias for the command that is called source. What the source command does is that any variables that are defined inside the script or the file that follows it is going to have the scope of the local shell. Let's return back to our discussion of variables. And let's have a look at our script.sh. Let's make some changes to this file. Or let's just leave it as it is, echo var2. And I'm going to unset var2 because it's already exported, so I'm going to unset it. Unset is the command that is used to remove the variable or remove the value from a variable. Just leave it as if it was uninitialized or just deleted. So if I echo now var2, I have nothing. Now let's assign a new variable to var2. This is a local variable like this. Okay, and I'm not gonna export this variable. I'm just gonna leave it at the scope of the local shell. var2 is local to only the current shell. Now, if I try to execute script.sh, of course nothing is gonna be displayed because I did not export var2. But watch what happens if I use the dot before script.sh. It's going to print the value of the variable. This is a local variable. And it was printed although I did not export it to the shell. That is because the dot or the source, this is also the alias for the command that's called source. Both of them are the same, they are aliases for each other. Is going to execute the script in the context. It's going to execute the bash script in the context of the current shell. It is not going to open a new shell, it's going to execute it inside the scope or inside the context of the current shell, and accordingly any variables that have been defined in the current shell are going to be immediately accessible to this script. And of course one of those is var2, which although it was not exported, it is still being accessed and the value that was stored inside it is printed to the screen. This is a local variable. So that is exactly what .bash underscore profile is doing. It is trying to make everything that was defined inside .bash rc, whether there were variables or aliases or anything that is related to your current environment, it wants those to be accessible to your current shell. It doesn't want it to open a new shell because then any variables that will be defined in this new shell will not be accessible to your current shell because they will be gone when this shell is terminated, when the command returns. But using the source command or the dot means that anything that is defined, any environment variables defined inside bash rc are going to be immediately available to your current shell. Okay, that brings us to the end of this lecture. In the coming lecture, we are going to have a look at aliases and where should you put them in the bash underscore profile or in the bash rc file. So until next lecture, take care. Alright, now an important question might pop up in your head. What to put in .bash underscore profile and what to put in .bash rc? Well, in order to answer this question, let's have a look at one of the cool features of bash, which is aliases. Let's clear the screen first, and let's say that you are used to a command like ls-ltr, for example. ls, of course, is for listing the files and directories by default in the current directory, and These are one of the most commonly used options with the ls command -l for displaying the long listing, which will give you some metadata about the file or the directory, like the owner, the permissions, the size, the last modification date, and so on. The T is going to sort the files in the directory by their last modification date, and R is going to reverse the sort so that the newest files come at the end. So let's see if we have a directory that contains a number of files like this. As you can see, the newest file comes at the end of the list, where the oldest file comes at the top. Of course, most system administrators are interested in last modified files, so the R option keeps those files always at the end so that they are visible to the user. Okay, so what if you are used to running this command lots of times so that you even do not use ls no longer without using the -ltr? You can just create an alias for that. So I can type alias ls, or just L if you want to create a small shortcut, equals ls-ltr, like this. Now whenever I type L, it's going to give me the long listing with chronological order reversed with the newest files at the end, just as if I typed ls-ltr. Whenever I am, just type L, and I'm having the output of the ls-ltr command. So you might be wondering whether or not this should be in your .bash_profile or .bashrc so that it is available for you whenever you log into the shell. Watch what happens if I added this to .bash_profile. Okay, I'm gonna install Vim quickly because I'm used to using it. Okay, now what happens if I add it? Let's just delete this line and add alias ls, or L equals ls-ltr. Then of course source, or .bash profile, in order to affect all its contents to the current shell. Okay, and now whenever I type L, it's going to display the long listing. If I logged out of this shell completely, log in back, go to /var/log, for example, type L. Okay, I have my ls-ltr. But what if I open the new shell? For example, if I typed L, okay, command not found. This means that the alias is not in effect. Why? Because aliases, like variables, are local to the shell where they were created. Unfortunately, there is no export statement for aliases to be promoted to environment aliases, if you wish to call them. They are and they will remain local to whatever shell they were created in. So if I logged out of this new shell and returned back to my old one or the parent one and typed L again, okay, I had my functionality back. So to address this situation, you will have to remove, let's go back to our home screen, home directory. You will have to remove it. You will have to remove this line from .bash_profile because it simply won't work except on your first shell, and add it to bashrc, like this. Just replace this with alias ls, or L equals ls-ltr. Of course, source it. And now whenever I open a new shell, no matter how many shells I open, that is because each time I open a new shell, the bashrc file gets executed. Now whenever I go to a directory where I have a large number of files and I want to display them or list them, just type L, and I have my listing with the options that I prefer. So that is one excellent example of what to put in .bashrc and what to put in .bash_profile. As a rule of thumb, put any variables or any environment configurations that can be exported or that can survive multiple shells or multiple subshells in .bash_profile, and anything that cannot be exported or whose scope is local to the current shell, like aliases, in .bashrc. Okay, so that was for the bash_profile and .bashrc. There is a third important file that bash uses, which is not created by default, but but you can certainly create it for yourself, which is .bash underscore logout. As the name suggests, this file gets executed whenever you log out of your current bash shell. So you can add your whatever commands, unset variables, or do anything you want whenever the shell exits. So let's say, for example, that I am interested in recording the last time I used the shell, or I used bash. So I can type here in .bash underscore logout echo last usage time is, and then I can display the current date and time. Okay, notice here that I used the $sign followed by those double rounded brackets or parentheses to execute the date command. We are going to cover that later, but just understand for now that this is going to get executed and the value of the date command is going to be substituted instead of this string. So last usage time will be, it will display the date and the time. Now let's save. And okay, I will need to add this to a file so that it is recorded, because otherwise it's just gonna print it to the screen and that's it. So let's use one of our redirection commands or symbols. We're gonna cover that later in this course. So I'm going to redirect that to file that is called last usage.text. Okay, so this text is going to be printed or echoed to a file that will be called last usage.text. If this file does not exist, it will be created. Okay, now let's log out of this shell. Let's log out completely of the system. Log in back. Okay, here we go. Last usage.text bash underscore logout is going to be executed when the last shell is terminated. If we cat the output, if we cat the contents of last usage.text, you're gonna see that last usage time is today, Saturday, March 24, and this is the time of our last usage or of our logout. Okay, so now we have covered .bash underscore profile, .bash rc, and .bash underscore logout, and the different scenarios where those files can be used. But we briefly covered quoting and command redirection, so let's cover that in a little more detail in the next lecture. So until then, take care. Alright, in the previous lecture we have covered quoting briefly. Let's have a look at the bash underscore logout file that we have edited in last lecture. Echo last usage time is and $sign parentheses date, and then redirect to a file that is called last usage.text. What we did here is that we used something called string interpolation. This is a fancy word that refers to expanding or substituting the value of a command inside a string, so that instead of typing last usage time is and then closing the code and then adding some sort of concatenation symbol and then adding $sign date, you can just add $sign date or the command inside the string itself, and it's going to be substituted using bash. Okay, let's see examples for this. I can say, for example, echo. Let's see if I have any other variables that I have defined in previous lectures. Of course, nothing. So let's define them again quickly. My name is Ahmed, like this. Now let's say I want to echo my name, but inside a statement like echo my name is, and I want to refer to the variable that is called my name. I can easily type it like this. And now my name is Ahmed. That is because I'm using quoting. Quoting here in bash has two kinds. The first kind is the double quote, and it is going to substitute the value of whatever command or variable inside the quotes with its real value. The other type is called single quotes, like this. Single quotes is not going to expand anything inside them. They are going to print the literal value of whatever comes inside. So $sign will not be respected, will not be expanded. It will just be printed like this. My name is $sign my name. It is literal. It is not a variable. It is not considered a variable. It's not expanded. Just the literal $sign my name. Same thing holds if you are typing a command. So let's say our current directory is $pwd. Again, but if we replaced the the single quotes with double quotes like this, things are going to be a little different. Let's add, you have two options here, either to use the environment variable pwd like this, or to use the command that will print the current directory in small letters like this, both of which will give you the same result. Our current directory is /home/vagrant. So this is called command expansion, and it is widely used in Bash. And notice here that when I wanted to execute the command, I use the $sign followed by a pair of parentheses, but that is not the only option or the only way by which I can expand or execute commands inside strings. I can use the backticks like this. The backticks will do the same effect as $sign parentheses, so I can type pwd like this. This will execute the pwd command, and both of them, as you can see, have the same output. Now, let's have a look at how to execute commands in the background. By default, Bash will execute whatever command you type it on the command line in what's called a foreground. This means that if the command is taking some long time to continue, the Bash shell will freeze, or in other words, you won't have access to the command line until the command finishes. Let's have an example. Sleep. Sleep is one of the commands that, as the name suggests, is going to pause execution of the current thread or of the current command line until a specific number of seconds has passed. So let's add sleep 5. In 5 seconds, you're not going to have any access to your shell until the 5 seconds have passed, and again, you will have access to the shell again. Sleep 5. This is used often in shell scripts when you want, for example, to check for something, check for the existence of a file that is supposed to be created, and you don't want to hammer the server with so many requests. So you just type sleep and give it a number of seconds to wait before checking again for the whatever condition you want to check for, the existence of a file, the presence of a service or a process that you have issued a kill command, and so on. But Bash gives you the option to run whatever commands you want in the background. This means that whatever command you are running, you can send it to the background by just adding an ampersand at the end. So sleep 5 followed by an ampersand is going to give you immediately the command line again. I can echo whatever I want, and the command is running in the background. When it finishes, it's going to give you done like this. So now sleep has finished what it was doing, which was actually just sleeping for 5 seconds. And when it's done, it just prints for you this message, done, and this is the job number, because when commands are sent to the background, they are called jobs and they have numbers ranging from 1. So 1 is done. And Bash has also a cool trick by which you can send commands that are already running in the foreground to the background. So let's say that we accidentally type sleep 60 like this. It's gonna sleep for 60 seconds, and I pressed enter. Let's say that this is a long-running command that you have typed on your shell script, on your command line, on your Bash shell, and accidentally you forgot to add the ampersand at the end. Pressed enter. Now you will not have access to your shell for 60 seconds. But what if you want to have other commands to run? What if you want to check for a log file, for example, or something? You can easily just press Ctrl Z, that is Control plus the letter Z or letter Z. This is going to pause execution of the current foreground process or the current foreground command, and it's going to send it to the background in a stopped mode. As you can see, the job now is having the stopped state. But what if you want to continue this execution? All what you have to do is just type BG for background, then $sign and give it the job number. So the job number here is 1. So I'm going to give it $sign followed by 1 and press enter. This is going to continue whatever the command was doing, but this time in the background. Now I have access to my shell. I can do whatever I want. And if I want to return back to the command, like for example, if this command does not have a log file to monitor, or it does not have any way to see what it is doing except if you invoked it in the foreground, I can easily type FG for foreground, $sign, %1, and unfortunately the 60 seconds has passed. Let's run that again, sleep 60 seconds, and then Control Z, and then BG $1, and then FG for foreground, sorry, %1, %1 again, and I am again in the foreground or in the interactive mode of the command. Now I can, for example, press Control C to terminate it, or I can watch whatever messages it is printing if there are any. So that is how you can run commands in the foreground and in the background. You can also use the no hop command, which is short for no hang up, no hop. No hop is used to run commands that will not hang up or will not terminate when the bash shell is terminated. Let's say, for example, that you want to run again sleep for 60 seconds, and you want this command to run even if the bash shell has terminated, because the bash shell is the parent for this process. The bash shell is the binary or the program that started this command or this process. So when the bash shell terminates, by default, anything that the bash shell has created, any processes, any commands that are running, are terminated accordingly. But we can override this behavior by using the no hop command. So no hop sleep 60, and of course add the ampersand at the end because you are intending to terminate the shell. Now it is running in the background. If I exit the shell completely, log in back again, and of course I won't have any access to this sleep command because it is now disowned, or it is not running under the control of the bash shell. It is running, if I apply ps-ef to get the current running processes and grep sleep, I can see that I have sleep 60. Now it is running in the context of the init process, which is the father or the parent of all processes on the system. This has nothing to do with bash. This is something that the kernel creates. So bash now has no idea about this command. It cannot control it. It cannot bring it to the foreground or the background. The only way you can terminate this is just to use the plain old kill command like this. Give it the process ID kill 3012, which is the number or the PID of the command or the process, and now it is gone. Okay, that brings us to the end of this lecture. In the coming lecture, we're gonna see more and more bash tips and tricks. So until then, take care. Each command that runs on the bash shell has something called an exit status. The exit status is a number that indicates whether or not the command was successful or not. You might be asking, what is this good for? Let's say, for example, I ran ls-l, or without -l, just ls, and I give it gibberish. Just a file name that's supposed to be existing, but it doesn't, obviously. I press enter. Okay, ls cannot access whatever I type, no such file or directory. As a user, I clearly understand now that I have made a mistake. I have typed the command with the wrong argument, and accordingly, I am given an error message. But what if you ran such a command inside a shell script? And what if this command has some other commands that were dependent on its output, or that were dependent on whether it succeeded or it failed? You will have no idea of whether or not this command ran correctly or it ran into problems, because the script is going to run unattended, or in other words, is going to run in one go. The user is not going to be there to monitor each and every step of the script. That is the role of the exit status. Let's examine the exit status of this command. It can be examined by querying the contents of a special variable in bash that is referred to as $? The $? contains the exit status of the last command that ran on the terminal. In our case, we are having an exit status of 2. I'm not interested in the number. Actually, this number has little interest to us as developers or system administrators, because the only thing that we are interested in is whether this number is 0 or not. If it is 0, this means that the command has exited successfully. It has executed whatever it was intended to execute, and it exited successfully. If it is a non-zero, this means that it ran into problems, and by convention, the number may refer to the type of problem that this command encountered. So, for example, the developer that wrote this command might return a number of 1 if it's a permission denied, a 2 if the file was not found, a 3 For example, if there is not enough disk space to write whatever it was writing and so on. However, most of the time, you are just interested in whether or not the exit status is 0 or non-zero. Again, how can this be important? How can this be of any good use to us as DevOps engineers? Let's go ahead and see one of Bash features that are very, very widely used, which is the if conditions. The if condition, if you are coming from any background that has any programming languages, you will sure know that the if condition is an integral part in any programming language. An if condition is going to test for some condition, like for example, if 1 is greater than 2, or if a file is empty, or if the user has permission to log in, and so on. You might be used to using the if conditions in some languages like Java, C#, or even scripting languages like Python, Perl, or PHP. Might be used to using if like this: if 2 is greater than 1, then echo 2 is more than 1, like this. Fi. By the way, this is the way we write if conditions in Bash. It's an if, then the condition, then write then, and the command, then fi at the end. This is the if stanza in Bash. But have a look here at what happens. Bash 2 command not found. That is because if conditions in Bash works in a different manner than in other languages. If condition monitors the exit status of whatever command that has been passed to it. So in other words, I can write if ls something, of course this doesn't exist, then echo command ran successfully fi. Of course nothing has been written, command ran successfully is not written, but the output of the ls command has been written. No such file or directory. Let's add an else statement. Else echo command failed. Okay. Now we have command failed written. That is because it examined the exit status of ls, and it found that the exit status of this command is non-zero. Accordingly, it printed or it executed whatever command came after the else part of the if condition. So that is how the if condition works in Bash. It works on the exit status of the command. And the exit status is not used only in the if conditions, it is used in other Bash command constructs. Like for example, if you want to execute a command and execute another command after it if the first command succeeds. So again, ls something, I can just mimic the if condition using something that is called using an AND or an OR statement. So ls something and like this, echo found something. Of course, nothing is going to be printed. This is exactly the same concept that I've written here, but it's just a shorter way. ls something is not existent, no such file or directory. But if I ls something that exists, a file that is already there, and again, echo found script.sh, it's going to be printed. The AND here is going to take whatever exit status was on the first command, and if it is 0, if it is true, it is going to execute the second one, the second command. Otherwise, it's not going to execute the second one. Okay, this is just a minified version of the if condition. The opposite of it is the OR. I can say ls again, script.sh, or echo not found, like this. Of course, this is not going to be printed because script was found. But if I typed something like this to mess with the file name so that it doesn't exist anymore, I'm gonna see that it has not been found, okay? And because the exit status is so important in Bash scripting and in logical operations like the if or the AND or the OR statements, there is a special command that is built in inside Bash that is called test. All what this command does is it provides an exit status of 0 or non-zero. So test, like this, and it takes a very large number of command line arguments to test for nearly everything that you can think of. So let's say, for example, that I want to test for the existence of script.sh. Notice here that the ls command is not the best way to do this, because first, it will display the name whenever you run the command, so you will have to come with a workaround for this, like for example redirect the output to a file or to /dev/null so that it does not get printed to the screen like this. So in all cases, ls is not the best option to test for the existence of a file, but the test command is going to do this for you. So if I type test-f script.sh, nothing is going to be printed, and that is what is intended, because we are going to chain this command to an if condition or to an and or statement. If we examine the exit status, you're gonna see that it's 0, which means that script.sh does exist. So I can write test-f script and echo found script.sh. It's going to be immediately printed, found script.sh. On the other hand, you can also type the or. Of course, nothing's going to be printed because the script is found using the f command line argument. Okay, and the exit status is also used in constructs like the while loop that we're going to visit at the end of this course. In the coming lecture, we are going to have a look at command redirection, so until then, take care. Hello everyone, welcome back. Any process in the shell by default has at least 3 channels for data transfer: the standard input, the standard output, and the standard error. Now, those 3 channels are used by the shell to communicate with any process that is running on the system. Let's say that you want to echo hello world like this. Echo hello world. I'm sorry, this has to be in single quotes because the exclamation mark has special meaning in bash. Okay, hello world. This has been printed by default to the standard output, which is the screen. But what if you want to redirect this standard output to something else? In other words, to a file. You can just do this by using the greater than sign or the right arrow, as it's sometimes called, and then you give it a file name, like for example, hello.txt. Now, nothing has been printed to the screen because I have redirected intentionally the standard output of echo to point to a file instead of the screen. Now, if I cat the contents of hello.txt, I'm going to see that I have hello world printed there. If you want to append instead of creating a new file, because if this file contains data, they're going to be overwritten by default. The file is going to be wiped clean, and whatever text was here is going to be printed here. If you want this behavior to be modified, you can just use double arrows or double greater than signs, and you can just say hello again. This is going to append to the file instead of overwriting it, so hello world, hello again. You can also redirect the standard input of a process. The standard input by default comes from the keyboard. If I type ls like this, I am giving bash, which is the current program that is running, a standard input from the keyboard, and I'm adding a command. I'm typing a command, l then s, which is the command ls. What if I want to redirect the standard input to be coming from a file? Easy enough. I can create a file that is called commands, like this. What I'm doing here is just for demonstration. So let's just add ls and echo this command is coming from a file. Okay. And now I can just type bash, redirect the standard input to be coming, instead of the keyboard, it's going to be coming from commands.txt. What this is going to do is that it's going to execute whatever commands or whatever text has been contained in commands.txt to the bash binary. And as you can see, the output of the ls command followed by the output of our echo command. Of course, this is just complicating things. This is just for demonstration. Of course, you could just type bash followed by commands.txt and it's going to be executed, or just self-execute commands.txt by adding the execute permissions and giving it optionally the shebang for /bin/bash. But you get the point. A cool trick of bash regarding redirecting the standard output is something that is called the here docs. Here docs will take more than one line of input, more than one line of text, and add it as a standard input to a command. So let's say, for example, I type a command like cat, and then I'm using the double less than signs, followed by a symbol or a string. You can add whatever you want. I often use EOT for end of text. You can just add EOF or whatever, like this. But as a convention, it's in all caps and it's something descriptive like end of text, end of file. You get the point. Then you can type, this is some text that spans multiple lines. Then when you are finished, just add EOT on a separate line without any spaces before or after. Press enter. And this is going just to echo whatever you type. This is because the cat command is taking its standard input from those lines. So you might be asking, what is this good for? I just echoed or I just mirrored what I typed to the screen. Well, if you type that same command again, but this time you also redirected the standard output to a file like message.text, for example. Now this is a message. Then EOT. Notice that nothing has been printed, no longer to the standard output or to the screen, but everything has been saved to the message file, the text. So this is a very handy way to add text to a file without using an editor like Nano or Vim or Pico. Let's say, for example, that some shells, if you have been working with a lot of systems, some shells are restricted so that you cannot use an editor at all. So you don't have access to VI or Nano or Pico. And sometimes you want to add a shell script, a quick shell script to a file or store some data to a file using the cat command, which is available in each and every shell that I have worked with. You can just use this trick and add the text to a file using the redirection symbols. This is called the here docs. Let's try it here, docs. Okay. Now another redirection symbol is called the here string. It is the same as the here docs, but it uses 3 redirection symbols instead of 1, 3 less than signs, and it takes only one line of string as a standard input to the command. So you don't have to use the EOT because naturally you're not going to span more than one line. So you just use this redirection symbol and add whatever text you want just on one line. Once you press enter, this line is going to be fed as a standard input to the command. So what is the best example for this? It's the passwd command. If you have been working in system administration, you for sure know that passwd is used for resetting passwords. So let's create a user. Let's call it test user, for example. And now we want to set a password for this user, but we don't want the hassle of typing the password twice and ensuring that the password is correct, although it's not echoed to the screen. If I try to type passwd test user, I'll have to type a password and then repeat the password. And notice that whatever I type is not echoed to the screen. Maybe this causes some inconvenience for you as a system administrator, and you want to type the password on the command line. Of course, don't use this in a production environment or in an environment where your passwords are visible to people around you. I'm just giving this to you as a demonstration. So you can use the here string for this as follows: sudo passwd test user, then add the stdin option to passwd, which means that I want the passwd command to take its input from the standard input instead of its own prompt. And then I'm going to type the here string and add whatever password I want to assign for test user. Let's say test pass. As you can see, changing password for user test user passwd, all authentication tokens updated successfully. This means that the password has been set successfully for test user using this command. This is the same as using this, but of course it's shorter. I can also use the EOT that I used before, the here docs, test pass, EOT. It's the same output and the same effect, but of course this is much shorter. Use this if you want to use one line of text only as the standard input for a command. That was how to redirect the standard input and the standard output. Let's have a look in the coming lecture at how to redirect the standard error. So until then, take care. Hello everyone, welcome back. The standard input, the standard output, and the standard error, as we mentioned in the previous lecture, are at least one of several channels that are available to any process or command that is running on the shell. And in order to differentiate between different channels, which of which is a standard input, which of which is the standard output, the standard error, and other channels, each channel is given a number. So for example, the standard input is having the number of 0. 0 refers to the standard input, 1 refers to the standard output, and 2 refers to the standard error. And these are also referred to as file descriptors. Let's clear the screen. So when I typed echo hello world and I redirected the output to hello the text, I should have added 1 and redirected to hello the text. But Bash automatically added this for me. It automatically inferred that using the redirect symbol like this without any numbers is going to redirect the standard output by default to the file. But I can be explicit and I can add 1 like this. It will have the same effect. Okay, notice here that, sorry, I have to remove the space. It has to be just no space between the symbol and the number, file descriptor number. Okay, now cat hello the text. You can see that hello world is printed. I redirected the standard output to hello the text. And in the previous example, when I used bash and I redirected the standard input to be coming from commands to text, I should have added 0 like this before the symbol. Like this. But as I just mentioned, bash automatically infers the redirection symbol, this one as redirecting the standard output, and this one as redirecting the standard input by default. But sometimes we want to redirect something else, like the standard error. This time you must use the file descriptor number. If you want to make sure, I can just redirect the standard output to a file like out the text, like this. As you can see here, the error message is the only thing that I have, while the output of the ls command is stored in out the text, like this. But what if I want the other way around? What if I want to redirect only the error message to a file? I can do that like this. Change the file descriptor name to be 2 instead of 1, and perhaps you may want to change the file name to be error.txt like this. Now I have the standard output to the screen, which is the default location or the default target of standard output, which is the screen, and any errors that happens or that is resulting from this command are going to be stored in a file that is called error.txt. Cat error.txt. You're going to see that I have the message that appeared. Sometimes you may want to redirect both the standard output and the standard error to a file. This can be used in one of two ways. One of them is a longer one, but it will be used for demonstration. The other one is the shorthand. I'm going to explain both. So now I want to redirect everything coming from this command, the standard output, and the standard error to a file. So I will redirect first the standard output. Let's be explicit. 1 to out the text. And 2, which is the standard error, I want to tell bash that I want to redirect the standard output. Okay, again, I forgot this space, like this. I want to tell bash that I want to redirect the standard error to the file descriptor that has my standard output, which is 1. If you want to refer to a file descriptor that has already been defined, that has already been used, you can just add an ampersand before it, like this. So now I am redirecting the standard error to whichever file descriptor present at 1. Between brackets, the standard output. If I press enter, of course nothing is going to be placed to the screen, because everything now is in out the text, the standard output and the standard error. So this is the long way of doing it. The shorter way, since you now understand how it is done, is just to add an ampersand before the file name. So just redirect without any file descriptor numbers, then and out the text. Like this. This is going to give you the same output as before. Now, what if you don't want to store the standard error for some reason? Let's say that you are running a shell script and you are aware that some of the commands that are going to run are going to produce some errors, and you don't want those errors to pollute the screen for the user. You are aware that they exist and you just don't care. They're not causing any harm or any problems. You can just redirect them to a special device file that is called /dev/null. So let's return back to one of our examples, and let's say that I want to redirect the error to something that won't be displayed either to a file or to the screen. Just get rid of it. Just add /dev/null, which is a special device file, and it's gonna get rid of anything that gets redirected to it. If I press enter, now I only have the output of the command, which is the standard output, commands to text, hello to text, but the error from trying to ls a file that does not exist goes to /dev/null, which is again a special device file that gets rid of anything that gets passed to it. Which brings us to the notion of device files. A device file in Bash or Linux in general is some sort of hardware abstraction. If you have read about Linux or Unix before, you're gonna see several times that everything is a file in Linux. Everything is a file. So let's say, for example, that you want to access a device file that refers to a disk. They are located by default in /dev, of course short for device, /sd, followed by a letter. So /dev/sda refers to the first disk, the first SATA disk in your array. SDA1 is the first file system, or the first partition on this disk. The second SDA2 is the second one, and so on. So these may look to you like files, but in reality they refer to hardware. They refer to disks. So Linux has a number of device files, and let's have a look at one of the interesting device files that you may not be aware of. Let's say that you want to send a command to a service that is running on a port, a network port, whether on your local host or on a remote host. Of course, the de facto command for doing this is telnet, the telnet command. But what if telnet is not installed? Of course, one of the easiest options is to install it, but sometimes you may be on a restricted platform or in a machine that is not connected to the internet, or for some reason or another you don't have the luxury of installing telnet. You can use one of the special device files with Bash to mimic the functionality of a telnet command. So let's first install a command that is called nc or netcat. This command is going to be used to open a port for us, just an arbitrary port that is going to receive our data. We are going to use nc, which is short for netcat, and we're going to open a port 2020, redirect whatever data that is coming through this port to a file that we are going to call network.txt. Of course, this is going to be run in the background. Okay, now if you want to access this port, if you want to send some command or some text to this port, and you don't have telnet, you can easily use echo followed by a special device file, which is /dev/tcp, then the name of the node or the machine where this port is running or the service is running. In our case, it's localhost. Then the port number. In our case, it's 2020. And pass in whatever you want to this hello from a non-telnet client. Redirect to this device file. Once you do, of course, the nc is going to exit because it has received text or data from the network. But if we can't network the text, you're going to see that I have hello from a non-telnet client. Congratulations, you have successfully established a connection or tested a connection to a port using nothing but the echo command and the bash shell. So that is one cool trick that you can do with bash whenever you are in a system that does not have a telnet and you want to establish a communication with a network port. That brings us to the end of this lecture. In the coming lecture, we're going to have a look at functions and how they can be used in the bash shell, and we're going to finish this course by exploring the different types of loops that can be used in the bash shell. So until then, take care. Alright, hello guys and welcome back. The last part of this section, the bash section of our course, is going to tackle functions and loops. A function, if you have worked with some other programming language, you probably know that a function is just a group of commands that are executed as one go. You might be asking, so isn't that what a shell script does? Well, that is an intelligent question, and yes, this is exactly what a shell script does, and functions are nothing more than shell scripts, except that they have a couple of differences. Let's have a look. Let's get inside script.sh and let's create a function. Functions in bash are created as follows. Function, the keyword function, followed by the function name. Let's say my name. Okay. Then a couple of curly braces like in the C programming language and other derivatives like Java and others. Then you can add whatever code you want. This code is going to be executed whenever this function is called. So I can say echo, then let's say echo my name, which is a variable that we're gonna declare in a moment. So let's say my name is Ahmed, like this. And then we're gonna call this function say my name. Okay. If we execute this script, as you might expect, it is displaying Ahmed. However, if we have another script, let's say script2.sh, and again bin bash echo my name, of course, you already know by now that this is not going to work if we called this script. Let's just give it the execute permissions first. And if I go to script.sh and I try to call the second script from inside, of course, this is not going to work. It's going to give me just an empty line. And of course, you should be aware by now that this is because we did not export the variable from the first script to the second. And that is one of the main differences between functions and scripts. Although a function behaves like a script, it gets called like this, say my name. We don't need to export the variable to be accessible from inside the function. It has immediate access to whatever variables that have been defined inside the script. That is because functions get executed in the same context as the parent bash shell or the parent shell. It is the same as if I typed source script.to.sh. Now, if I run this again, okay, the function printed the variable and the script printed the variable, but by default, functions behave as if they have been called like this, source script2.sh, as if they have been called like a shell script that is called using the source or the dot, if you wish to call it, like this. So that is one important difference between functions and shell scripts. The second difference is that functions are stored in memory, not when they get executed, but when they get defined. So if you have here a function that has been created in the .bash_profile, for example, it gets immediately stored in memory when you open a shell script. So when to use a function? Functions can be used as aliases. For example, let's go to the bash_profile or the bashrc in this case, because we want our functions to be available in all our shells. And let's have a look at this example. Alias L is ls-ltr. But what if you want to have an alias or a shortcut that is more intelligent or slightly more complex than this one? Let's say that we want to clear the screen. ls-ltr is fine. It gives me the output of my current directory with long listing and reverse chronological order. But what if you want to add grep? Of course, this is the pipe symbol. It's going to redirect whatever the standard output of this command to the standard input of another command, which is grep. In our case, grep is a filtering command. If you haven't heard about it before, it is a filtering command. It's just going to filter the output that it gets according to what you supply. So if I type text, it's going to display whatever has the word text inside, like this. So here I'm going to display only files that contain txt or text. Okay, so what if you want this to be a little bit automated? we can create a function for this, and we can give it an argument, and this argument is going to be what grep is going to ask for, or what grep is going to filter. Let's go to bash rc, and let's create a function that is called, of course, we're not going to call it ls because this will create a confusion. So let's call it ll. So an alias is L, and the function will be ll. And this function is going to execute ls-ltr. It's going to pipe to grep. And I want grep to take an argument that is going to be passed to the function. Arguments are passed to shell scripts and functions the same way. They are passed as follows. $1 is the first command line argument. $2 is the second command line argument, and so on. So here I'm going to design this function to take the first argument and pass it to grep as the filtering string. And let's end it. Of course, this is something that an alias cannot do. Let's exit and source bash underscore profile. Now I have access to the function. If I type ll and add, for example, net as the filter string, I'm going to display. Okay, let's have a look quickly at bash rc. Of course, I have the ll command is already an alias that has been defined. Let's use another symbol. Let's name it lsf, for example, for list filtered. Okay, because the ll by default is an alias that is already defined somewhere else. That is already defined. So this created a name collision. Now let's again source bash profile and use lsf, give it net as the string that we are going to filter with, and now we have any files that have net inside, which is network, of course. Let's say, for example, I want to filter with sh. Now I have ls-ltr grep at anything that has sh, which of course is a script and script2. So that is one important difference between shell scripts and functions, and that is also a difference between functions and aliases. Functions are much more powerful. They can be created for you to create handy commands that can be used inside your shell scripts. Now let's have a look at loops. A loop, as the name suggests, is a command construct that is going to loop across a number of items, whether those items were files, strings, list of words, list of users, whatever you might think of. So the first kind of loop that we are going to explore in bash is the for loop. The for, or the for in loop, if you wish to call it. The for in loop is going to loop through a list of items that are passed on the command line. The for loop can work with files by default. So I can say, for example, for f, which is the variable that is going to be used in the loop. So for f in, and then I can say extension dot sh. An asterisk here is called a globbing character. It just means anything that ends in .sh. Any characters, any strings that have .sh at the end, then do, and I can do whatever I want with the files that are going to be returned by this loop. So I'm just going to echo them, which is a very good practice to do if you are designing loops. Before you execute a command against whatever the loop is going to bring you, just echo the variable of the loop. Just echo what the loop is going to bring you before executing a command, especially if that command was destructive, like, for example, renaming files or even deleting them. Then at the end, you type done. This is the construct. This is how a for in loop is constructed. For a variable in, then a list of items that you want to loop in. Then the construct itself starts with do, ends with done, and between them, whatever commands you want to run on the variable, this variable will get substituted each loop run with the next item in the list. In our case, we have only two items, script and script2.sh. And notice here how we do not have to use ls, for example, or any subsidiary or any auxiliary commands to get the file names from the current directory. They are automatically brought to you by the for loop. So let's say, for example, that I want to rename those files. Instead of .sh, I want them to be .bash. So instead of echo $f, I can just use the mb command and $f should be $.bash. Of course, this is not going to remove .sh. If you want to remove it, you will have to use substrings, which will be a bit complex, so just let them just be like that. So I'm just gonna add the extension at the end. If I ls now, or just use my function that I've created earlier, which is lsf, and give it sh as a filtering character, I'm gonna see that I have script1 or script.sh.bash and script2.sh.bash. I have successfully renamed all the files that end in .sh with a new extension appended .bash. You can do all sorts of cool things, like for example compress large files, for example, or delete old log files and so on. The for loop is very powerful, and it is used very, very often in bash shells. The other most widely used kind of loop is called the while loop. The while loop is going to be executed whenever or as long as a condition is true. And it works the same way the if condition works. It takes a command and it examines the exit status of that command, and whenever that exit status is 0, the loop will continue to run, otherwise the loop will exit. So a very well-known usage of the while loop is to be combined with the read command. The read command is one of the shell built-ins. The read command is going to read whatever text is passed to it from the standard input, and it's going to store it in a variable. So I can say read line, then redirect the standard input to be coming from, like for example, /etc/passwd. Now if I echo $line, it's going to contain the first line of text from /etc/passwd, because read took the first line and assigned it to the variable that is called line. So we can combine this functionality in a while loop to read all the lines of text from a file and perhaps execute something on those lines, like the following: while read line, then do, let's say, echo line, and done. And let's redirect the standard input of this while loop, in this case it's the standard input of the read command, to a file that is called /etc/passwd, for example. As a might guess, it has printed all the lines of the file. So let's say that we are interested in getting just a line that contains the word vagrant, which is our current username. So I can add grep like this, grep vagrant. This is only going to display the line that contains vagrant. Of course, this is a much longer way of doing just this. Grep vagrant from /etc/passwd. This will give me the same output, but this is just for demonstrating how you can use the while loop and the read command to read lines of text sequentially from a file. Now what happens now is that read line is going to give an exit status of 0 as long as there are more lines to be read from /etc/passwd. But once the file is ended, once the end of input is received, the exit status of the read command is going to be false, and then the while loop will immediately exit. So that is how the while loop works, and that brings us to the end of this part of our course on the bash shell. In the coming part, we are going to start working with one of the most powerful scripting languages, which is Python. So until then, take care.
Hello everyone and welcome back. This is the second part of your Script Essentials course in the DevOps e-degree from Avionics. My name is Ahmed, and in this part of the course we are going to explore Python version 3 in particular. And Python 3 does not ship by default in some Linux distributions, so we are going to start by installing it. And installing Python can be done easily using the default package manager of your Linux distribution. So let's ensure that we are in the correct path. The vagrant file is in our path, and issue vagrant up. Okay, now the machine is up and running. Let's get inside it. Vagrant SSH. And if I run sudo yum search Python 3, which is the latest, you're gonna see that I don't have any items or any packages that contain Python 3. But if I install a package that is called epel-release, this is a package that will
allow me to use the EPEL repository with the yum command, which contains some extra packages that don't ship by default with the CentOS installation or Red Hat variants in general. Now I can, let's first search for it. Sudo yum search Python. As you can see, it is querying the EPEL repository. Okay, and you have several Python 3.4 here packages. You can just use sudo yum-y install Python 34, which is short for Python 3.4. This is not the very latest Python package. The latest one at the time of this recording is 3.6, but the latest version that is supported by the CentOS machine is 3.4. If you are running on an Ubuntu machine, you can just use apt-get install Python like this, and it will get you the latest version, which is 3.6, because at the time of this recording, again, it is supported on Ubuntu version 17.10 or higher. Once you issue that command, you're going to install Python 3 on your system. If you are on a Windows, you can just go to your browser and type download Python to be directed to the Python default page. Just go to Python 3.6.4, which is the latest. And of course, I'm here running a Mac, so it's giving me the binary package for Mac. If you are on Windows, just go on this link if it isn't already open for you, and you can choose the installer, and it's going to install Python on your machine. It's as easy as running the wizard. If you want to use brew on a Mac, for example, you can just use brew install Python 3 like this, and it is going to install the latest Python 3 package for you using brew. It depends on your preference. Python is a portable package, and it is very easy to be installed on multiple machines. Okay, Python 3.6.4 is already installed. So let's get started with how to use Python in your DevOps career. Okay, the first thing we're going to start in Python is variables. I just first want to note that this is not a complete Python course. We're just gonna scratch the surface. Python is a very powerful scripting and programming language, and whole books have been written about this subject. I'm just going to give you the basics of the language so that you can use the different third-party libraries and tools that are written in Python in the DevOps tools that we are going to use later in this course. So let's start our editor. I'm using Visual Studio Code, and I've created this file, Python essentials.py. This is the file that we are going to use to explore the language. So let's get started. Let's just get this out of the way. As you can see, Visual Studio Code gives us a screen that can be split into two parts, the editor part and the command line part, in which you can execute whatever code you write here. So the first thing we need to know about Python is how it uses variables, or how it refers to variables. In the Bash shell, variables have been created like this. My name, for example, is Ahmed. Remember, we couldn't use any spaces before or after the variable name. And if we want to refer to a variable name, we have to refer to it like this, echo $my name. In Python, things are different, of course. You are free to use spaces before and after the equal sign, but because this is a string, you have to quote it in single or double quotes. And if you want to print it, you don't use the echo command, use a command that is called print, and you give it the name of the variable just like that, print my name, without any $sign or any symbols before the variable name, just print my name. If we go here and type Python 3, Python essentials.py, you're gonna see that I have the variable name printed, Ahmed, in the command line. If you want to, you can opt to make this file self-executable the same way you did with the Bash shell by using the shebang like this. This is not just for Bash, this is for any file that you want executable. Any script file that you want it to be self-executable can use this technique. Just we need to know where is the location of our Python package. I think it's in USR local bin Python 3.6. Yes, that is correct. So I'm going to use that path here, /usr slash local slash bin slash python 3.6. Now all what I have to do is just give the execute permission to this file, Python Essentials. And now whenever I want to run Python code using Python 6, I'm going just to type / and the file name, and it is going to get self-executed. Okay, so that was about variables in Python. And we have also seen strings, and strings are coded in single or double quotes in Python. Let's play a little with those strings. Let's say, for example, that I want to type the name and convert its case to lower, for example. You can use the lower method. A method, if you don't already know about it, is a function. It can call it a function or a method in Python. It's just a group of code that gets executed in one go. Using the dot here, I am intending to execute the lower function on whatever was in the variable. This variable is a string, and the string is an object that offers a lot of functions or methods, one of which is the lower method like this. Using the lower method against this variable is going to convert its case to lowercase. So if I type Python Essentials again, I'm going to see that I have all the letters in the value of the variable turned to lowercase. And whatever case I use in this variable, it's going to be always converted to lowercase. That is very useful if you want, for example, to have a username that is logging to your application or to your website, and you are running Python and you want to ensure that this username is correct. People often are not obliged to abide to a specific case when they write the usernames. Only passwords are case sensitive, that is by convention. So you might find a user that typed his or her name like this, JDoe, for example. And you could have already a user in your database that is called JDoe, like this. By the way, this is a comment. Comments in Python start with a hash sign or a pound sign. So you want to ensure that JDoe does exist in your database. So if you try to equate JDoe in this case with this one, it will fail because Python is a case-sensitive language. So the recommended practice is to convert the case to lowercase and to store all usernames in your database in lowercase. Then it's very easy to test for equality, whether JDoe exists in your database in lowercase or not, and you can authenticate the user. You can also use other popular functions with strings, like for example upper, which is of course the opposite of lower. It's gonna convert the case like this, JDoe. And you can also use the title. Title is going to capitalize the first letter of the value or of the string, so you will have JDoe like this. There are a lot of other functions that can be used with strings in Python. And if you want to concatenate two strings together, let's say f name is John and l name for last name is Doe. If you want to print both of them, you have two options, either to concatenate them using the plus sign like this, f name plus, then an empty space, then plus, then l name. Now let's clear the screen under bottom terminal and run it again. Okay, it's John Doe. This is one option. And the print function or method offers you another way to type or to print several strings together by using the comma. The comma will automatically add a space between the first and the second variable or values. It's gonna just give you the same output, but it will use less typing and it is more readable. So that was all for Python installation, and we had a brief idea about strings and variables. In the coming lecture, we're going to have a look at one of the very important aspects of Python language, which is the lists. So until then, take care. Alright, welcome back. Lists in Python are arrays in other programming languages. So if you are coming from a programming language like Java or C# or C or C++ or any higher level programming language, you have sure came across the concept of arrays. An array is just a group of values that belong to a single variable. In Python, these are called lists. A list can be created as follows. You give it a name, like for example users, and then you open square brackets and enter values like this: user1, user2, user3. All those belong to one and only one variable, which is users. Now you can reference any item in this list by its index like this: print users, then open a square bracket and give it the index of the item. lists in Python, as arrays in all other languages, are zero-based indexed. This means that the first item in the list or in the array is having the index of 0, the second item is having the index number of 1, and so on. Now, if I executed this script, you're going to see that I have user 1, which is the first user, which is the first item in the list. Okay. However, Python offers you some cool ways to access lists which may not be available in other languages, and that is what makes Python perfect as a scripting language. It offers you quick and dirty tricks that you can use to quickly achieve the task at hand. So let's say, for example, that you want to access the last item in the list. So in another programming language, you will have first to find the length of the array or of the list. This can be easily done in Python by using the len method. The len method, which is short for length, is going to give you the length of the list. So you can just use this with a print command and get the index of the last item in the array like this. Users, len users, but then you will have to subtract 1 from the length because, as we have just mentioned, lists in Python are zero-based. This means that to get the last item in the array, you'll have to subtract 1 from the length of the array or list. So the length of users is 1, 2, 3, but the last item in the list is having the index of 2. So you'll have to subtract 1 from the length of the list in order to get the last item. Let's run this code, clear and run the code. Okay, I have user 3, but Python has a shorthand for this, like many other shorthands that we are going to see some of them during this class. I can use print users, and then I'm going to give it -1 as the index. -1 is going to, or negative numbers in general, are going to start from the left, from the right of the list all the way to the start. So when I say -1, I'm referring to the last item in the array. If I am referring to -2, it's going to be the item before the last, -3, the one before it, and so on. So this is going to give you the very same output as this long one, this long command. Let's run it. Okay, it's user 3, but this is much easier to read, and it is much less code, and it's easier to debug. Okay, let's see now how if we want to catch the one before the last, it's user 2, and so on. You get the point. So what if you want to add or remove elements from a list? You can directly change elements in a list by assigning new values to them. So for example, what if I want to assign a new value to the item at index 1, which is the second item in the list? I can easily say users1, which is again the second item in the list, not the first one, and I can say that this user should be named jdo instead of user2. Now I can just use print and give it the whole array, and Python will handle printing the array for me like this. Just gonna give you the whole array nicely formatted, square brackets, commas, and everything. And as you can see, the second item in the array has been changed to be jdo instead of user2. So that is how you can modify items in the array. How about adding elements or items? You can add an element to the end of the array by using the append method. So I can use users.append and then add whatever username you want, like Peter, for example. Now let's again print the values of the list after we did that change. And now you have user1, jdo, user3, and Peter. Now you have 4 users or 4 items in your list. That is because the append method has appended the item that I have added here, Peter, to the end of the list. You can even start with an empty list and add elements dynamically as they become available. This is very, very common in programming because most of the time you don't have access to that data firsthand. You obtain this data either from a web page, from an API, from a database, or even from the user, and you take this data and start processing it. And to process the data, you will have to add it to some variable, typically a list. So let's say that we have an empty array like this, users. Now I can just use users.append, and I can start adding items to the array, like Ahmad, for example. Now print users is going to give me just one item. I can add more and more users as I want, like for example John, and so on. So now you have 2 items in the array and so on. This is how you can add items dynamically to an empty array. And again, this is how you will use list. And again, this is how you will use data in your real-life programs. Data is not available for you when the program starts. It is the job of the program or the script to grab this data and start processing it. You can also use another important method with lists to add items to the list, which is the insert. And the difference between the insert and the append is that insert or will add the item at a specific index. It adds at a specific index. Let's see an example. So now we have users. They contain 2 users. Let's add a third one. So there's Ahmed, there is John, and there is Linda, for example. So now we have 3 users. What if I want to add another user, but I want this user to be in the second place, not the last, the second place? I can easily use users.insert, and insert is going to take 2 arguments. An argument in a function is the data that you pass to the function in order for it to work correctly. So this insert function needs 2 arguments. The first one is the index where you want to insert the item, and the second argument is the item or the value itself. So I can say Mary will be at position 2. Now if I execute this script, I'm going to see that I have Ahmed, John, Mary at position 2. This is not the second position, this is the second index. So it is the third position in the list or in the array. Remember, this is a 0-based index array or list, so 2 means the third position. If you want to add it to the second position, you will have to add 1 instead of 2. Now you have Ahmed, Mary, John, and Linda. So now what if I want to remove users from the list? What if I want to remove items? I can use the pop method for this, users.pop. And if I used pop just like that without any arguments, it is going to remove the last item in the list. So let's execute this, clear the screen and execute the program. Now I have only Ahmed, Mary, John. Linda, which was the last item in the array, has been removed. However, pop has an extra functionality, which is that it will hand you the item or the value that it has removed from the array. So I can say that removed equals users.pop. Then I can add a help message, removed, comma, then the user that I have just removed. Now if I run again the script, you're going to see that I have the array after I have removed the last item, which is Linda, and then the help message is telling me removed Linda. This is what I have removed from the list. Pop is handing it to whatever variable I am assigning it to, which is removed in this case, and I'm printing here removed and the name of the user that has been removed. But pop also can accept an argument. If you give an argument to pop, it will be the index of the user you want to remove. So what if I want to remove the first item in the array or in the list rather than the last? If I add pop 0 like this, if I run the command again, or the script, you're going to see that now I have Mary, John, Linda. Ahmed has been removed. These are the basics for working with Python. You will have to be very comfortable with working with lists because lists are used extensively in Python. So you will have to be very proficient in working with lists. And as you can see, they are very easy to grasp. They are very easy to work with. Python provides many functions and many shorthands by which you can use lists and benefit from what they offer. The last thing we're going to cover in removing items from a list is that how to remove an item by its name. So let's say that I know that I have a user that is called John in my list, but I don't know what is the exact index of this user, but I want to remove it. This can be easily done. Let's just delete this line and last one. And I can use the remove function. The remove function is not going to take an index. Unlike pop, it's going to take the name of the item itself. So if I want to remove John, it's going to loop through the array. You're going to have a look at loops later in this course. It's going to loop through the array or the list until it finds a user whose name matches the name that you have added here or supplied to the function, and it's going to remove it from the list. Now, if I execute the script again, I'm going to see that I have Ahmed, Mary, and Linda. John has been removed. Okay, So that was all for this lecture. In the coming lecture, we are going to have a look at how to sort lists, and then we're going to move to loops. So until then, take care. Alright, hello and welcome back. You may want to sort a list alphabetically, or if this list contains integers or numbers, it can be sorted numerically. So if you want to sort an array, all what you have to do is just use users.sort, the array name, and pass in the sort method, which is going to sort the arrays in alphabetical or numerical order, depending on the type of data that you added to the array or to the list. Now I have Ahmad, Linda, and Mary, A, L, and M. If you want to make sure, you can just remove this line to keep our John user in its place, and if I run it again, let's change the order. It's sorted alphabetically by default, so I'm gonna change the order. Let's add Mary in a different index so that it is now unsorted. And the sort command is gonna always give you the sorted array with Ahmad at the start, because it starts with an A, then J, L, and M. But notice now that this has changed the value of the list permanently. The list is internally changed. Sometimes you may want to have an idea about how a sorted list will look like without changing the actual values inside the list. You can do this easily by using the sorted function. The sorted will have a list as its argument or its parameter, and it's going to just give you an idea about how the list will look like when it is sorted. So I can print sorted method and pass in users list as a variable. This is going to give me the sorted list, but if I tried to print the original one, you're going to see that it stays intact. So the original list order was John, Linda, Mary, and Ahmad, and the sorted one was like that. So use either of them depending on your exact needs. One of them is going to change the values inside the list permanently, so we will never go back to the original order of the list. The other one will just give you an idea about how the list will look when it is sorted, and if you want to, you can just assign a new variable to the value of this method. So I can say sorted users equals sorted, then pass in users array, and now I can just print sorted users. Now I have two lists. One of them is sorted, the other one is not. So now I can have the sorted one and the unsorted one. So if I want to make any comparisons between both of them, they are both available to me. Now let's have a look at loops. Loops are an important concept in Python and in programming languages in general, and they are often or almost always used with lists and arrays. In Python, it is very easy to use a loop, and the most common loop in Python is the for in loop. Let's have a look. So now we still have lists of our users, and the simplest form of the for loop is like this: for, then you give it a variable, any variable that is going to be substituted by each and every item in the list. So let's say u, so for u in users, then a colon, and a colon in Python marks the start of a stanza or the start of a call block. In other programming languages like C or C++ or Java, for example, you might see something like this. Let's say for int I is 0, I is less than 10, I plus plus, like this. If you have programmed it in any programming language before that has the C style, you may be familiar with this style of coding. Then you open a curly brace like this. Curly brace and a closing curly brace, and this is how a call block is defined in other languages. In Python, this is done by using a colon. Just a colon, but whenever you type in a colon, you will have to indent code that comes after it. By default, it has 4 spaces to the right, and this marks the start of a block. Once you get back to the original indentation, which is at the start of the line, this marks the end of the block, as we're going to see. Let's omit this code. Let's return back to our loop. Now, for u in users, then you can do whatever you want with the u, which again is going to be substituted by each and every item in the list. So I can simply print username is u, just like that. Let's clear and execute. Okay, username is John, Linda, Mary, and Ahmed. I can be even a little creative and convert it to title case so that it gives me a more elegant view. Those are my usernames, and the case has been changed to indicate that this is a name, a person's name. Okay, you can do all sorts of things with the item inside the list by using the for loop. And sometimes you may wish to mimic the loops found or the for loops found in other languages. Like, for example, maybe you want to create a loop that is going to run for like 5 times, do something for 5 times, and then exits. You don't have a list, you don't have items to loop through, but you want to loop for a specific number of times. This can be easily done in Python by using the range command. The range command by default is going to take 2 arguments, a starting number and an ending number, like this. This is going to give me a list like range from 1 to 10, but not including 10, from 1 to 10. So I can say for I in range 1 to 10 do, or colon to start the code block, and then let's print the value of I, just to see what happens. Executing, I can see that it printed everything. It printed 9 numbers, starting from 1 ending to 9, and notice that it did not add the boundary or the last number here to the list. It stops at n minus 1. Okay, so that makes it a perfect candidate if you want to use it with lists. Like, for example, I can type range from 0 to the length of users, for example. Then I can refer to users item list by their index, like this, print users I. This is very common in other programming languages. You loop through the list of items or through the array, and you loop through the index. So Python gives you both ways. You can just use this shorthand to loop through all the items in the list, and the variable is going to be substituted automatically for you at each and every item. Or you can do it the old way by using the range operator and get the starting value and the ending value, and it's going also to loop through the array, through the list, and give you the same output like this. But the advantage of using this is that you can start at a specific index like this. For example, I can start at 1 instead of 0, which will start the loop at the second item in the array or list. So I'm going to start with Linda instead of John. I can also play with the last item, so I can just get the second and the one before the last. So execute, and I only have Linda and Mary. However, and again, Python has its own shortcut for this. Let's see. If you want to print parts of the array or the list, this is called slicing. So I can say print users, and if I want to mimic the behavior that I did here, which is printing all users from the second one till the one before the last, so this is just the second and the third, I can do it as follows. Print 1, which is the starting index, colon 2, this is the ending index. Just like that. It will give you, oh sorry, it's 3 because I want, this works the same way as ranges. It will take the upper boundary and print the one that precedes it. So if you want to print the second or the third, you will have to start at index 1 and add 1 to the last index. So here we have Linda and Mary, just the same output as this one, except of course it's printing it in a list, because the output of slicing is always a list. So you can do a for loop in a slice like this, for you in users 1 colon 3 print you, like this. And now it's going to give you the same output as in this one. Slicing is very powerful. You can do all sorts of things with slicing, not just printing parts of lists. You can do something like this. Users 1 and leave the colon and leave the upper bound empty. This means that I want everything or every item starting at the second item in the array or index 1 till the end of the array or list, whatever that may be. This is very useful if you do not know firsthand the length of your array. What if you have some data that has been grabbed from a database and you don't have an idea about what is the array length? Of course, you can use the len function or method to find the length of the array and then do something like this. But again, Python offers you a much better and more readable way of doing this. It involves less typing. So I can do something like this. It's clear. Now you have all the items in the list starting from the second item till the last one. And I can also benefit from the negative indices that is supported by Python. So I can print from the second index till the one before the last. So this is going to be only Linda and Mary. Let's execute. Of course, it's Linda and Mary because I have opted to choose the second and go one step back from the last. So I want to print the first and the one before the last. Okay, I can do that the other way around by placing the empty variable before the colon instead of after it. So I can say print everything up till index number 2, which is the third item in the list. If I execute, I have John, Linda, and Mary. And let's see the whole array first in order to see the difference. So I have John, Linda, Mary, and Ahmed. But using this form of slicing, I am printing starting at John, Linda, Mary. It just printed everything till the third item in the array or the list, or the item that is having the index of 2. Okay. In the coming lecture, we're going to have a look at a powerful way of dealing with lists and changing the items in a list in place, which is called list comprehension. So until then, take care. Alright, welcome back. Let's say that you were instructed by the security team in your organization that every username in your list must contain at least 1 digit. So we have now this list of users, John, Linda, Mary, and Ahmed. And the security team has advised you that this username is not valid. It must contain at least a number, a digit. So now you need to loop through all the usernames in the list and add a number or 2 to it. Let's see how we can approach this problem. First, choose a number. We could have written code to generate random numbers, but let's keep the example simple. So let's say that we have chosen that the number that we are going to add to each user is going to be 1, 2, 3. Let's, of course, make this a string because we are going to concatenate the username and the number. So if you left this like this is an important concept to grasp. If you left this like that and you printed, for example, or you tried to make something like this, username, if this is a username plus 1, 2, 3, this won't work. Because the username in this case is going to be a string and this is a number, so concatenation won't work. So for that, you will need to ensure that this number is stored as a string and not as a number. Okay. Now, the traditional way of dealing with this problem or with this request is to loop through the users. Let's do a simple loop for I in range. And the reason I'm using range is going to be obvious in a moment. 0 for the start and the length of the list of the usernames or the users, like this. So for I, or in range 0 to the length of users, we are going to type users I equals users I plus the num. Okay, so let's first discuss why I did that loop instead of something like this for you, for example, in users, which is the traditional way of looping in a list. Because if I did that, how am I gonna change the items in the list? For example, for you in users, I could say u is u plus num. Okay, that is fine, but the list stays intact. You have changed each item in the list to contain a number, but the list itself is still intact. You could have created a new list, for example, like users2. I don't want to complicate things, I'm just explaining to you my logic. You could have created a new users list like this, and then say new users, users2 dot append, and put the user. You can see that this is very, very complicated. You are creating now a second list, and then you're gonna substitute, and then you're gonna have two lists, one with the correct usernames, or the original usernames and the other with usernames with numbers appended to it. So the correct way to approach this problem is by using a range and addressing each user by its index. This way we can change each user in the list to be containing a number. Now let's print users after applying this change to it, and let's see what happens. Okay, now we have our requirement fulfilled. Each username does contain a number attached to it. John123, Linda123, Mary123, and Ahmed123. But fortunately, Python has a much easier way of dealing with such cases. Let's comment out this. Actually, let's comment out all. Let's first delete all the code that we no longer need. Okay. Let's clean our code a little. Okay. And let's comment out those 2 lines. And let's use what's called list comprehension. List comprehension is a fancy word, but it's very easy to understand. All what we have to do to change each and every item in a list is to just assign the list to a comprehension. A comprehension starts with a square bracket as if you are creating a new list, and then y plus num. You are specifying what you want to do with each item in the list, and this item is going to have whatever variable you choose, whether it was u, I, or any variable of your choice. Then for u in users. That's it. In one line of code, I will achieve the same effect of this loop. Let's first execute the code to see if it works. Okay, we have the same output as the one produced by the loop, but it is shorter, it is more readable, and it is easier to understand. Users, which is the list, this list is going to be changed in place, and then you assign to it the list comprehension. This part of the comprehension is whatever you want to do with the item in the array or in the list. In our case, we are concatenating a number to it, then the normal for u in users. This is called list comprehension. Let's get back to strings for a moment, and I don't think you're going to be surprised to know that strings are treated in Python as lists of characters. So let's remove those for the moment. If I say, for example, message equals hello world. This is a message, let's say as a variable that contains hello world. This message is a list. If you want a proof for I or whatever, let's say S for string in message, print S, like this. If I execute my code, I'm going to see that I have each and every character in the string printed. Why? Because, as we just mentioned, a string is nothing but a list of characters, and we are printing here each character in this list on its separate line. So print S is going to print you hello world. Okay, so let's do something cool with this list, since now we understand that a string is a list. Let's apply list comprehension to it, like for example, message equals S plus a space. So we're going to add a space between each character and the other for S in message. But if you want to print it, it won't be printed as a string. If we try to print message like this, let's clear the output in the terminal. It's going to be printed like a list. We need to convert it back to a string because a string is a special form of lists. In order to do this, I'm going to use one of the very commonly used string functions, which is join. Join is going to take a string, any string, and it's going to take a list. In our case, it's message. And what this is going to do is that it is going to convert the list into a string by joining the items in the list with whatever character I chose. So here I chose nothing, no characters, and I'm going to apply join to this string, to this separator, and give it the message or the list as an argument. So what this is going to do is that it's going to join those characters together and add a separator, which is nothing. This is going to be clearer in a moment Now let's put this in here in the print to see what it looks like. Okay, hello world. And as you can see now, because this list contained each and every character with a space after it, so hello world is printed in this fancy form with a space between each and every character of it. And if you want to understand join in a little more detail, you can even use the join to achieve the same result without using list comprehension. Like, let's comment out this line of code and add a space here. So now I'm gonna join each and every character in the list. Hello world, adding a space as a separator. If you run this code again, gonna see that it has the same output, just the same as what was achieved by the list comprehension, but it's again more readable and consumes less code. You can add any character you wish as a separator, like an asterisk, for example. Let's see. Now you have an asterisk between each and every character in the list. Okay, that was all for lists, and I hope you got a clear grasp and a clear understanding of lists. We're gonna visit them later, both in this course in Python and in later courses in this program when we discuss DevOps, when we, for example, use Ansible, because Ansible is a DevOps tool, a configuration management tool that uses Python as its language. So lists, I have to stress again and again, is one of the most widely used concepts in Python. You have to have a clear understanding of it. So I hope by now you built a solid foundation about this concept. And in the next lecture, we are going to start by discussing the if conditionals in Python. So take care. All right, welcome back. If conditionals in Python, or if conditions, are very easy. They are much easier than if conditions that we studied in Bash. They do not work by examining the exit status of a command. They just work like any if condition in any other higher level language like Java, C, C++, or C# or any other language that uses if conditions. And it just tests for the Boolean value of true or false of whatever expression that is passed to it. So the easy stuff, if 1 is greater than 2, then we have the colon, which, as we mentioned before, starts a code block. Print something is wrong, or something must be wrong, and that, of course, will be the case if 1 was proved to be more than 2. Else, print that's right. Okay, now if we execute that, of course, that's right. 1 is never greater than 2. So this expression gives a Boolean value of false, and that is why if jumped to the else statement and printed, that's right. Let's have a quick revision to the different expressions that if can accept. You have the greater than, of course you have the less than, you have the less than or equal, you have the greater than, the greater than or equal, and of course you have the equality, which is presented by a double equal sign. So if 1 is equal to 1, you can say that's correct. Let's omit the else. Okay, and the non-equality, which is an exclamation mark followed by an equal sign. Of course, nothing's going to be printed. All this is basic stuff. That's why I'm going through it quickly. Let's now have some practical examples. What if, for example, you have a username that has been grabbed from a database or something, or a user has entered it on the screen. Username is jdoe, and you want to authenticate this user. So we have a user and we have a password, both of which have been grabbed by the program from some source, like, as I said, a web form or a database, and you want to authenticate this user. So you say if username equals jdoe, and now you want to also ensure that the password that the user has entered is the correct one. It's not sufficient to have a username that is correct. You also need to have a valid password. So use the AND keyword here, and AND keyword is going to test for more than one condition, and for AND to evaluate the whole expression to true, both conditions must be true. So AND password is equal to pass 1 to 3. Now, if the username is not jdoe and the password is correct, the whole expression will be false, If the user is correct, it's John Doe, and the password is incorrect, both, the whole expression is going to be false. And this is exactly what we want to achieve. We want to ensure that both conditions are true in order to evaluate the whole expression to be true. So if that is the case, print welcome, and the username, just greet the user. Else, let's print an error message, sorry, wrong username or password. Okay, let's try this out, clear the screen. Okay, welcome Jado, because clearly we have the correct username and password. If we enter the wrong username, it's gonna be sorry, wrong username or password. If we enter the correct username but the incorrect password, again, it's gonna be sorry. Okay, so this is how you can use the AND expression in order to evaluate more than one condition in the same if statement. Now, let's say that you are searching for the username Jado in the user's name list. In the username list, let's say that we have a list here that is called usernames. Let's create it quickly. Usernames. Jado, let this be the first one. And Linda, Ahmed, Peter. Okay. So that is a list of usernames. Now you want to ensure that Jado is in this list in order to further authenticate this user or to apply any sort of processing on this user. You want to ensure first that this user does exist in the database, assuming that this list has been grabbed from a database, for example, or an XML file or whatever source of data you have. I can easily use one form of if, which is if whatever item you want to search for in usernames. Give it the name of the list. Okay, so this expression using the keyword in is going to evaluate to either true or false depending on whether the item exists in the list or not. So if it exists, let's print Jado found. Else, let's print no user name found, for example. If we execute this, okay, Jado found. And because, as we mentioned in the previous lecture, strings are treated as lists of characters, you can use this to quickly search for a string inside a string. This is very handy in Python. You're gonna use it lots of times in your daily scripts that you are going to use as a DevOps engineer or even a system administrator. Let's say, for example, that you have a string of text, maybe a long string of text, like for example, a message, an email, for example, that reads, please restart the Apache daemon, for example. Now you want to search for the presence of the word Apache. Let's say that this is a message that has been grabbed from a log file or from an email or whatever. You can say if Apache in message print Apache found, like this. Okay, so now you have Apache found. This is a very handy way to search quickly for a string inside a string. Of course, searching for strings inside strings can involve much complex scenarios, and you can of course involve regular expressions and other forms of complex pattern matching. But for the easiest and simplest form, just searching for a string inside one, you can use the if condition with the in keyword. You can also negate the presence of a string inside a list, or if you are searching for an item, by adding not, like this. So let's say that we're looking for Nginx, and let's say Nginx not found. If Nginx is not in the message, of course Nginx is not found. So using not before in is going to negate the condition, and it's going to search for the in presence of the string or the item, if this is a list, in the list. Okay, so whether this is a list of characters or a string or just a list of items like this one, it's gonna negate the condition. Now let's have a quick exercise, since now we have a list of usernames. Okay, again, let's say that we want to authenticate a user. So we have a list of usernames and we are searching for the presence of the user in the database first before attempting to authenticate it. But what if the user that entered the username entered it in the incorrect form, like this, JDO, for example. Remember, previously in this course, we mentioned that the usernames are by default not case sensitive, so users may opt to enter the usernames in all caps or a first letter caps, or and so on. So you can just deny user access if he or she entered the username in the incorrect case. Only the password should be case sensitive. So let's say that we want to search for the presence of the username that is called JDO in any case. So I can write code like this for you in usernames. So instead of searching for the username using our previous form like this, if JDO in usernames print JDO found, for example, this clearly won't work. Printed nothing. That is because JDO is printed in the incorrect form. Let's assume it is in the other word around. Let's say that the user is stored in the database in small case and the user entered it in the form or in the prompt as this case. Of course, it's going to be the same output because both of them do not have the correct case. So now I have two options. The first one is the easier. I can just ensure that whatever the user entered is in lowercase. So since this is a string, I can apply lower like this. And now JDO is found. That is because whatever the user has entered in the prompt or in the form is going to be converted automatically to lowercase, and it is going to match against a username in the list if it exists, because everything in the list is in lowercase. So this will ensure that whatever case the user chose to enter his or her username, it's going to match if it does exist. The other solution is a longer one. Just adding it here for demonstration, I can just type for you in usernames if you to lower equals the user that we're looking for, then print JDO found and break from the loop so as not to continue searching through the rest of the list items needlessly. And again, it's going to give me the same output. Let's say that the user has entered it in whatever case. Okay, so JDO is found. But of course, the first method is much more concise, much more readable, and it gets the job done. Okay, so that is all about if conditions in this part of the course. In the coming lecture, we are going to start with tuples. Then we are going to move to dictionaries, which are another important concept in Python. So till next lecture, take care. All right. So far, we have learned about lists, and as I've mentioned, they are an integral part of Python. They are used everywhere, and you'll use them lots of times. Another slightly similar concept or similar construct or data structure in Python is called tuple. Tuples are all like lists, except for one important difference. They cannot be changed. They are immutable. That is, once they are created, they cannot be modified throughout program execution. They can be created as follows. Let's say that we have our list of usernames, and we also have a tuple for privileges. A tuple can be defined or created using a parenthesis instead of square brackets. Then you add your items the same way you add them to a list by using a comma to separate them. So I have, for example, a user and an admin. So as you can see, it becomes very obvious why you want to put those in a tuple. You don't want a user accidentally creating a new role or changing a role or a privilege. So we have two privileges, user and admin. They must not change. They must stay this way. So let's say, for example, that a user accidentally did something like this. priv0, you change or you try to modify a tuple the same way you try to modify a list, except that it will not accept your change. So priv0, let's say user tried to promote his or her role to be moderator instead of the user. As you can see, actually Visual Studio Code is putting this underline, the red underline here, to inform me that I have an error in my code. If I try to execute this code, it's going to give me an error. Tuple object does not support item assignment. You cannot change or assign new items to a tuple once it is created. Now, aside from that, you can work with tuples the same way you work with lists. So for example, I can type for p in privileges or priv print p, or do whatever you want with p. You can make anything except changing the tuple itself. Of course, we need to add here parentheses. Okay, so you have user and admin. You can use this to authenticate a user, to inform him or her about the privileges that they have, and so on. Okay, let's now move to a third very important concept in data structures of Python, which is the dictionary or dictionaries. A dictionary is like a list, except that it accepts items as a key value pair. What does that mean? Let's have a look. Let's say that you have a username, just one user, and you want to identify this user. Let's say that he has or she has a username of JDoe, but you want more about this user, not just the username. You want his or her age, job, address, city, and so on. You can add it in a list like this. So I can say user JDoe for the name, age is 31, job is DevOps engineer, city or country is the US, for example. But let's say now that you want to access the job of this user. Having to memorize the positional argument or positional place in the list. So I have to memorize that the username is at index 0, the age is at index 1, the job is at index 2, the country is at index 3, and so on. This is just hard to memorize, and it will cause all sorts of confusion when you try to work with that in live code. Another more suitable solution is to use a dictionary like this, user, and then instead of a parenthesis, you use curly braces like this. And you can actually add some space for yourself so that it's more readable. And you can add a name for the value. So let's say name or username, just to be clearer. So a username is John Doe, comma, for the next item, age is 31, comma, and job, DevOps engineer, and country, finally, is US, like this. Now imagine the difference that this code does. It's clearer, it's easier to read, it's easier to retrieve, and you won't get any confusion. But whenever you want to have a property of this user, all what we have to do is, let's say, print user, and then you just reference the name of the field. So username, for example, I have immediately John Doe. If I want a job of this user, DevOps engineer, so I can write, for example, a statement like this. It will be very easy. The username is, and he is age, like this, old, he works as, and lives in, like that. So how about this? If I print this now, or if I execute the code, as you can see, the username is JDoe, he is 31 years old. I forgot the years here. Let's add years so that it's correctly typed. He is 31 years old. He works as DevOps engineer and lives in US. So imagine now the ease of retrieving different values about an item by referencing the name of the property or the name of the value. Okay, but dictionaries get even more powerful if they are added to a list. A list can have any type of items, including dictionaries. So I can, for example, have a list of usernames again, but this time, let's say users. This time it's gonna be a list of dictionaries instead of individual items. So I can, again, add a new line. It's perfectly legal to add new lines when you are creating lists or dictionaries in Python. It won't complain about this. And let's create our first list. Let's say username. I'll keep it short this time. Username is, let's say, Linda, and job, let's say, an operator. Now let's add a comma. Let's add another username. Can just save some space since I will have only 2 items in the dictionary, so I can add them like this. Now I can copy and paste and just change the values quickly. So username Linda, username Peter, username Ahmed, operator, sysadmin, DevOps. Like this. So now I have a list of 3 users. Let's just omit this one. We're gonna work with a list. Now I have a list containing 3 dictionaries, each of them representing a different user. Now I can easily loop through this list, like for example for you in users, and you can work with each individual item in the list as a separate dictionary, the same way we worked with a single dictionary before. So I can say print username is you username and job is then just you job, like that. Now let's clear and execute the code. Username is Linda, job is operator, username is Peter, and job is sysadmin, username is Ahmed, and job is DevOps. So that is how we can use dictionaries to reference different parts of data, to add some identification, to add some metadata to the values that we add to our data structure. In the coming lecture, we are going to continue working with dictionaries. We're going to see how we can add items dynamically or remove items dynamically from a dictionary that has been already created, and also how to loop through the dictionary using keys and values. So until next lecture, take care. Alright, welcome back. What if you want to modify an item in a dictionary? Let's say, for example, that we have a dictionary like this. User. Let's just take one of those and put it in a user. Okay, let's say that we want to modify the username to be something else instead of Linda, or let's say the job. Easily, I can say user and then refer to the job or whatever the item name. I can give it a new name, like for example, tester. Okay. Now, if I print the user, can just give me the representation, the string representation of this object, which is a dictionary. So the username now is Linda and the job is a tester. Easy enough. Now, what if you want to add a new item that wasn't present before in a dictionary? So for example, let's try to add a password for this user. A password is not present in the dictionary. I want to add it. So I can say user password. This is a new item in the dictionary. Let's say is pass123. Now I will have password added to the dictionary, and it has a default value of pass123 or a value of pass123. So let's get back to our users list, and let's say that we want to modify each and every user in this list to add a default password, which is pass123, like this. Each user created must have a default password. That was a requirement of your security department. So we can write code like this. For I, because now we are going to refer to an index, for I in range 0 len usernames or users to loop through all the indexes of the dictionary from 0 till last index in the list, because this is a list, this is not a dictionary, this is a list. And then I'm going to go to users I and add a password field like this and set it to pass123 like this. After we finish, let's have a look at users to see whether or not that worked. Okay, now we have each and every user has a password set to it. As you can see, username Ahmed, job DevOps, password pass123. Same holds for each and every user in the list. Now, you might be asking, in a previous lecture, we used code like this and we said that Python provides list comprehension for solving such a problem, for changing a list in place. But actually this won't work with assigning values or with assigning new items to a dictionary or with item assignment in general. So if you are asking about solving this issue like this, users equals you, password equals pass123 for you in users, because we used to do code like this when we were concatenating numbers or digits to the username. Remember in the previous lecture, we used code like this, but unfortunately this won't work. It's going to give me an error because you cannot assign, as you can see, the arrow here is pointing at the assignment operator, the equal sign. You cannot assign new values in a list comprehension. So in this case, you are obliged to use this somewhat longer way of assigning items to a dictionary like this for I and give it a range of indexes of the users or of the list, and then in each index you can add whatever you want or make any modifications to the item of the list, which happens to be a dictionary, and here we are adding a new property or a new item, which is the password. Okay. Now let's say that we want the other thing, the opposite. We want to remove a key value pair from a dictionary. This can be done by using the del method or the del function. So let's say that after we added the passwords, we need to, ironically, remove it. So I can easily do for I, again, in range 0 to the length of users, open a colon to open a code block, and then I can use del method, then give it the name of the item that you want to remove. In our case, it's users, of course I for the index, and password. This code is going to delete the password field that we have just created in the previous loop. Now if I print, let's clear the screen, print again the users, you're going to see that password has been removed. Okay, so the del method removes an item from the dictionary by knowing its name, the item name, the key of the item. Okay, so now we are looping through a list of dictionaries, but sometimes you may have a dictionary that is long enough to need its own loop. So let's delete this code and let's create a dictionary that is longer. Say that I have a dictionary of languages that the users might be adding as their preferred language. The users will have to choose among a list of languages which of those languages are going to be used for their, for example, their interface of the application or whatever preference they are using. Let's say they have a dictionary of languages, lang equals, and I open a dictionary. Let's say that those languages will be set in the user's preferences for their interface, for example, and I want to have an abbreviation for the language for being used inside the application or inside my code, and also a friendly name for the language to be presented for the user. So, for example, I can have EM, let it be in small case, and the friendly name is going to be English, say ES Spanish, AR for Arabic, and let's say IT, for example, for Italian, like this. So now I have, let's say, let's this be lang, sorry, to be more realistic. Now I have a dictionary that is long enough of its own to deserve its own loop. So how can I loop through a dictionary? It has keys and it has values. When I used to loop through lists, it only had items, so I can just create a variable like u or I or s or whatever, and this variable is going to be substituted for each and every item in the list. But here I have each item has two items of its own. It has a key and it has a value. So how can I loop through this? Simply, if I just use a simple loop like for k in langs print k, this is going to print the keys only by default. Sorry, I forgot the parentheses. This is Python 2 code. In Python 2, the print statement or the print command did not need parentheses, but in Python 3, you're obliged to use parentheses. Okay, so now I have the keys printed, EN, ES, AR, and IT. So what if I want the values as well? If you want the values, you will have to make some modifications to the loop. You're going to add a comma, and you're going to add a second variable here. I can call it v. This is by convention for key and value, k and v, but you can call it whatever you want. You can call it key and value if you want to, like this. Whatever you want. This is just the name of the variable. You are not obliged to use any special words here, just any variable of your choice. And also you have to add or use a method here after the dictionary name, which is items. Okay. Items is going to convert the dictionary to a list of key and value names. Okay. Now you can print keys only, like key. It's going to give you the same output, or value. It's going to give you the values, or both if you want to. Key, can add a column to be more realistic, and value. Now you have each and every value with its corresponding key printed in a nice format. Okay, so that is how you can loop through a dictionary, provided that this dictionary is long enough to deserve its own loop. Notice that lots of times you will be dealing with lists and dictionaries that were created automatically for you by Python libraries, like for example, the results of a database query, so you will have to have a strong background about how to deal with them. That is how we are stressing in this course on dictionaries and lists more than maybe other aspects of Python code. Okay, that was all for this lecture. In the coming lecture, we're going to have a look at Python functions. So until then, take care. In this lecture, we are going to talk about functions in Python. Functions, or methods, as they are sometimes called, are a group of code or a group of statements that are executed together atomically or using one command or one call to the function. In Bash and in other languages, you may be used to writing functions like this. Perhaps the keyword function followed by the function name, then a pair of curly braces, and you type in the function. In Python, as well as Ruby, these are called definitions. So you type def for definition, then the function name, let's say for example say hello. Then of course you open a code block as you did with all other language constructs that needed a code block. You open a column, then you type whatever you want the function to do. So let's say for example print hello. That is a function, and the code like this will not work unless you call it. You have to call the function in order for it to work. So say hello. And the function optionally can take parameters. So you add here a double parenthesis like this, in which you can optionally provide parameters for the function. Those parameters are immediately available to the body of the function, so you can use it to process input from the user or from the calling code. Now let's first execute this code like this. Okay, the function works. Say hello does print the hello string to the screen. Okay, so let's quickly move to a real-world example. Let's say that you want to authenticate users on the system using a function so that you don't have to retype the code whenever a user needs access. So let's quickly create a dictionary of users. Okay, so we have here usernames or users. Let's call those users. Have a name, you have a privilege, you have a password. You have a name, you have a privilege, and you have a password. Okay, now we need to create a function that is going to authenticate those users. So authenticate, and in order to authenticate, you will need naturally two things or two strings, the username and the password. So I'm going to ask the function to accept two parameters, a username and a password, and then I will loop through the usernames that I have, or the users list that I have. So for you, for user, in users, then open a code block. If you name is equal to the username, we've seen code like this before. We are just incorporating dictionaries, lists, and functions to make it more real-world-like. So if the username is the username that is supplied and the password is the password that was supplied, return true. Return is what the function gives to the calling code. A function may return nothing, but often you will need the function to return something to the calling code. This return can be a value, it can be a Boolean value, it can be a string or an integer or whatever, it can be an object, it can be anything, a list, a dictionary. It's just a result of the processing that has been done. So more often than not, you will need to return something from your functions. In this case, I'm returning true if the user has been authenticated. And notice here that the return statement will automatically break the loop. It's gonna exit from the function. The return automatically exits from the function. So if you are worried about if you have like 1,000 users here and you are looping through these users until you find the correct username and password, you don't have to search the rest of the list needlessly and waste your CPU resources searching for a username that has been already found. Don't worry, the return statement will immediately break from the loop and break from the function and go to the calling code with the Boolean value of true to inform the calling code that yes, a username with the username supplied and a password have been found in the database, and of course this user should be authenticated. Otherwise, we should return false by default. This means that if this loop is complete without having a username or a password, whether because there is no username or password with the strings that have been supplied, or they have been supplied incorrectly, in all cases, you will have to return false at the end. Okay, and of course, there is a colon here because this is an if statement. And that is how you authenticate your users. So let's try out this code. Let's call authenticate, give it a username. Let's see what we have here. We have B. Cranston and Egon. Let's try John Doe, our username that have been used throughout this course, and pass 1, 2, 3. And let's put this in an if statement. So if authenticate jdoe and pass 1, 2, 3, let's print welcome to the application, or whatever welcome message you want to print. Perhaps this will open a screen or open another program for the user, or whatever action you want to do if the user is authenticated. Otherwise, else print sorry, wrong, or non-existent credentials, or any message that will inform the user that he or she has entered incorrect credentials. Let's run this code now. Okay, sorry, wrong, or non-existent credentials, of course, because John Doe or jdoe and pass 1, 2, 3 does not exist in this list of users. Let's enter a user that does exist, B. Cranston, and a password of Millennium. Okay, like this. Now I have, okay, it was mistyped. Okay, let's run the code again. Welcome to the application. So this is how you can use a function to group code that can be used multiple times. This can be used anywhere in your code to authenticate users whenever you want, and to display a welcome message, or otherwise you can execute whatever command you want, execute it when the user is successfully authenticated. Okay. Now sometimes when you work with functions that are coming from third-party libraries, you will find that the README or the documentation of the library informs you that you have to call the function with something like this. So if the function is authenticate, you might find that they are asking you to type in the function like this: username equals and password equals. This is another way of running functions. It is, instead of relying on positional arguments. Now let's see. Authenticate here is accepting two arguments. The first one is username, the second one is password. So I can explicitly inform my function that the username that I'm passing is B. Cranston and the password is Millennium. The advantage of using this is not only you are informing yourself or the user of your function or the reader of your code what those parameters are there for, but you can also interchange their locations like this. So I can no longer be obliged to add them in a specific order. So I can put the password before the username as long as I am adding a key for my parameter. Now, if I run this code again, it will work as before. Welcome to the application. The user has been successfully authenticated because now the function is aware that the password is this one and the username is this one, regardless of their location. This is also very useful if you have a function that takes, like, for example, a dozen parameters. And believe me, yes, there are functions in third-party libraries and in existing libraries in Python that takes that number of arguments. So this way, it might be very confusing to remember the order of arguments, which comes before which. So it becomes very efficient to name your parameters like this, to add a name for your parameter in the function so that you and the users of your code know why those parameters are used and why they are assigned those values. Okay, that was a brief introduction to functions. In the coming lecture, we are going to see more ways of calling functions and more ways of placing parameters. So until next lecture, take care. What if you want to add a positional argument, or in other words, you want to add an argument or a parameter to the function without placing a key? Of course, this might be a rare case because if you want to use named parameters, why would you want to add a parameter without a name? But if you want to, if this is the case, you can add it just at the start of the parameter list. You cannot add a positional argument after a named one. So let's say, for example, that I want to authenticate a user using the username, the password, and the privilege. So let's add priv here, like this. Now, if you want to add privilege, you will have to add it here, like this. For example, admin. So now I'm authenticating the user with the privilege, the user, and the password. I cannot add admin at the end here because this won't work. If I try to do that, the code is going to give me an error, as you can see here. Positional argument follows keyword argument. You have to put the positional argument before the keyword one, like this. Again, this is a not so common case because you would normally want to do something like this. Since you are following this pattern, since you are naming your variables or naming your parameters, it's a common sense to add a name for each and every parameter, not just to mix them. But if you want to mix them, you have to ensure that the keyword parameters come at last. Okay. Now, Python also allows you to add default parameters. Sometimes they are called optional parameters. Let's say, for example, that you want this privilege. As you can see here, I forgot to add the privilege, or because I omitted the privilege, and the privilege or the priv is part of the function design. So here it is expecting a third parameter that is called privilege. What if this third parameter is not needed? Or let's say I want it to be optional. If the user wants to add it, that's okay. If the user does not want to add it, that's also okay. So I can add priv and then I give it a default value like this, priv equals user. This means that if priv is defined here like this, it will be honored and it will be accepted by the function. So let's say that you are going to use this privilege inside the function for some reason, and by default it's user. So if the privilege is not supplied, it's gonna default to user. If it is supplied, the function is gonna take whatever is inside the privilege. So that is called an optional argument. And as you can see, if I removed this argument from the list of parameters that I'm passing the function will still run correctly. If I added it, it will also run normally without any problems. Okay, so that is called an optional parameter. Now let's move on to function arbitrary arguments. Sometimes you may not be sure about the number of arguments you want your function to handle. Let's say, for example, that you have a function that will find the product of whatever numbers passed to it. Let's, for a moment, leave the authentication and the users. Let's omit this code for the moment. Let's say that we have a function like this, function or def multiply. I'm going to call it multiply. And we're going to use this function to multiply whatever numbers passed to it. You don't know firsthand how many arguments the user will pass to the function at runtime, so you create a function as follows, multiply, and here we need an argument or a parameter that will accept any number of arguments passed to it. This can be easily done in Python by adding an asterisk before the parameter name. So I can add num preceded by an asterisk. This means that num is going to be translated inside the function to a list of parameters. No matter how many parameters the user will pass, they are all going to be stored inside this num list. So let's see now how this function may work. I can, for example, give a result of 1 and then start my loop for n in num, which is the list. Result is going to be multiply equal to n. And what this symbol does, it's just the same as doing this. Result equals result times n. Just going to multiply itself by whatever comes after it, result times n. This is a shortcut for this statement, result multiply equals n. So I'm gonna loop through every item or every number that the user passes, and I'm gonna multiply it by result again and again until I have the final, until the list is empty, all the parameters that the user has supplied are finished, and then I'm gonna return the final result for me. If the user entered nothing, then the result will always be 1. Let's see how this works first. So multiply, then let's give it just one number like 5, for example. And let's print the output. So print multiply 5. Of course, it's going to be 5. What about 5 and 8? It's going to be 40. What about 5 and 8 and 10? It's supposed to be 400. Yes. What about 5, 8, 10, and 45, for example? Let's go higher. You get the point. But what if I pass nothing? Let's try. And because I'm passing in an asterisk, this means that the function may accept nothing. The list may be empty, because if the list contains nothing, it can still be used in loop. All what's gonna do is that for n in num, which is empty, result equals result times n, which is nothing, so the result will stay 1, and the result will be 1, which is of course not the best answer the user might get. So I can just add a little if condition here. If the length of num is 0, or in other words, if the num is empty, or if the user did not pass any arguments, just return 0, for example. Which makes sense if I am calling my function with 0 arguments. The reasonable result is just 0, like this. Okay? So that is how you can pass arbitrary arguments to a function. The function may accept any number of arguments, and as you can see, this is very common if you want to multiply numbers, for example. And if you want to mix arbitrary and positional arguments, this can be done in Python as long as the arbitrary items come as the last arguments. So let's say, for example, that I want to pass in a message to the function, a message that it's going to be supplied to the user, and this message is going to be like this: return message and result. Okay, so I can say the answer is, and then supply whatever items I want, 8, 5, 6, for example. Okay, and it's complaining because it's trying to add a string to an integer. So I can easily solve this by converting the result, which is an integer, to a string by using the str function, which will convert a number to a string. Now, if I run this code again, it's going to give me, let's just add a space here. The answer is 240. So here I could combine a positional argument, which is message, with an arbitrary number of arguments, which is whatever I pass after the message, and the function will correctly take the positional argument and add it to the result, and then use whatever was passed in the rest of the parameters as a list and multiply them together. Okay, so while this option in functions, in Python functions, are going to convert the parameters to a list, you can also have your parameters added as a key value pair, or in other words, a dictionary. Let's say you want a function that will create a user dictionary by accepting a number of arguments. So let's delete this function, and let's say that we want a function that's going to create a user. Let's return back to our basic example of users. Let's say that we want a function that will create a user like this: create user. And we have 2 obligatory arguments, which is the username and the password. And then we have a number of optional metadata that can be added to the user profile, like for example, the age, the job, the country, the preferred language, and so on. So if I added meta like this, it's going to be a list. So again, I will fall into the problem of having to remember the positions of the arguments. Let's demonstrate this. Let's keep it as an arbitrary number of arguments like we did before and see how we can do this. First, I will define an empty dictionary because this is the user that's gonna be created. Let's just call it user. Not result to be more obvious to you. And then username will be the username that's supplied. User password will be the password that has been supplied. And then I want to add whatever metadata was supplied in the argument list. So if I looped like I did through the list of parameters, like for m in meta, I want to be able to add user and then some key and then equals the value of m. You see? Now I need something. Now I need a name for the metadata that you want to add. I need a name for whatever property you want to add. Like for example, age is 30, job is DevOps. Okay, so I need this to be a dictionary instead of a list. To make the problem more obvious to you, let's say that I want to call this function create user, and I give it a name, which is Ahmed. I give it a password, which is ABC123, for example. And then I want to give it a list of arguments. Like for example, the job is DevOps engineer. The age is 30 and the country, for example, is US. Okay. So how would the code know that this is the job, this is the age, and this is the country? How I'm going to add this to the dictionary here, to the result, to the user? One way of doing this is to use the indexes. So if I know that the user is going to pass 3 parameters, I can use something like this. Comment out this code and can use something like this. User, this is the 0, this is the 1. So user 2 is meta 0. User 3 is meta 1 and so on. But you can see how this is becoming very, very confusing, and it can easily be error prone. This is not readable. This is not practical. So the correct way of doing this is to convert this argument list to a dictionary. This can be done in Python by adding another asterisk to the parameter. Now I can add this as a key value pair. So instead of adding DevOps engineer and 30 and US, I will add it as a dictionary like this. Job equals DevOps engineer, age equals 30, country equals US. Now I have access to those keys inside my code, inside my loop, as we learned in a previous lecture. When working with loops in dictionaries, I can just add k and v for key and value in meta, and user k for key is value. That's it. Now I can return the user. Okay, so now if the user equals create user and I add those parameters to the function, I can easily now print this user after it has been created, and it will contain the values that I have added, like this. Okay, I forgot here to add .items. This is mandatory if you want to loop through a dictionary. If you want to use the k and v, you have to add the items method to the dictionary. Otherwise, you can only loop through the keys. Okay, so now let's clear the screen and run the code again. Now we have a username created, username Ahmed, password ABC123, which is the mandatory parameters. And now we have all the metadata that we added to the profile, a job, an age, a country. I can add whatever I want to the end. Let's say language or lang, for example. This will automatically be added to the user when it's created lang English. So now you get the point. So this is how we can add arbitrary arguments to functions. You can either add them as a list or as a dictionary or both. You can mix and match them however you want, as long as you add them with this order. The positional arguments first, then any name parameter, like for example privilege or any other name parameter, then arbitrary parameters that are converted to a list like this that we have seen before when we multiplied multiple items, then finally the key value parameters in which you can add them like you add a dictionary like this. So this is the correct way of ordering your parameters, ordering the priority of your parameters, so that you write correct Python code that does not produce errors. Okay, that was all for functions in Python. In the coming lecture, we are going to see how we can add functions to modules so that they can be imported and used in multiple Python files. So until next lecture, take care. Alright, so now you know about functions, how to call them, how to design them, and how to pass parameters to them. Now let's see how those functions can be packed or grouped in files of their own so that they can be used in multiple Python code files. Now, why would you want to do this? This is a file called python-essentials.py. What if you have another file or another code that needs to make use of the functions that you have worked hard to create? One option is to just take a copy of those functions like this, authenticate and create user, and add them to the new code file to be used. But what if you want to make changes to one of those functions or both of them? What if you want to add more logic or to fix a bug? Then you'll have to go to each and every file where those functions are defined and make this change, which of course is error prone and it's a lot of time to waste. The recommended approach is to create a module file where you add those functions. Module in Python is just a group of code that can be used in more than one code file, or third-party libraries that you're going to work with Python, as well as the built-in libraries or built-in modules are just a form of what we are going to do now. Just create a new file. Let's save it and give it the name of any name of your choice. Let's say user functions, for example, .py, and let's add those functions here. I'm gonna cut them like this. Okay, so now we have just the users and the function. Of course, the function now is giving me an error because I have removed the function itself, the function body, then paste it here. Okay, of course, we will need to make some modifications. If you want to authenticate the user, you will need to add a third parameter to the list, which will be the users itself, the users list, because it has not been passed. And of course, because we have a positional argument here, or let's just remove this. We have a default parameter here, an optional parameter here. Let's just remove it and add users instead. So now whenever you want to authenticate a user, you will have to pass in the username, the password, and the list of users against which you're going to authenticate. Okay, so now I have an error here. I have a list of users, but I don't have the function that is going to authenticate those users and create new users. So you will need to add the following. Import, the import statement. You're going to use it multiple times in your Python code to import either built-in libraries or third-party libraries in Python. Import user underscore functions. This will just search the current directory for a file that is called user underscore functions.py, and it's going to import it. You don't have to add the py at the end. It's going to be interpreted automatically by Python. Now, the functions inside this file are available to you, but on one condition. You will have to prepend function name by the module name, user functions dot. Now we have create user. It does not have the error that the wavy line, the wavy red line has disappeared because now this is valid Python code. If I try to run it, it's going to run correctly. It's going to create the user for us and print it. Also, if you want to authenticate the user, you can do just that by using, again, let's say if user functions dot authenticate. Again, let's say John Doe, which does not exist. Pass 1, 2, 3, the user and the password. And the list of users must be passed for the function to work. So if this user is authenticated, let's print welcome. Otherwise, else, let's print sorry. Okay, that will be very concise. If I want this code, sorry, because of course John Doe is non-existent. If I added one, let's add the second one here. Again, an ABC123. If I try to authenticate this user, which does exist in my list, it's gonna print welcome. Okay, but what if you want to import just one or two functions of your module or your file? I can easily use a form like this. Instead of import user functions, I can say from user functions import. Then I can get the name of my function. Let's say create user. Now I only have one function in my code that is available. But then I don't have to prepend the function name with the module name because now I made it available by name. I made it available that I have a function that is called create user. It's part of user functions. So Python does not need to know where this function comes from. So I can easily remove this. And of course, I no longer have access to the authenticate function, so I'll need to comment out this code and just print the user. Okay, code still works, although I removed user functions module from the function name. Okay, you can add more functions to the import, or can choose more functions by adding a comma. So if I want both functions, the authenticate and create user, I can add a comma and add the function that I want to import. Now, if I uncomment this code, it will no longer give me an error. Just remove user functions again, because now I am explicitly telling my code that I have a function that is called authenticate that is part of a module that is called user functions. So I don't need to prepend the function name with the module name. Now, if I clear the screen and run the code again, okay, it's going to work as expected. Sometimes you'll need to make an alias for your function, especially if this function name is lengthy or is hard to remember, or for whatever reason you want to make an alias for it. You can just use the as keyword. So from user functions, import create user as cu, create user, authenticate as authenticate user. So au and cu. Now there is no presence, or there is no reference for Python for create user and authenticate. You have named it different names, so you can use just cu like this and au like this, both of which are going to work exactly the same as before. You can even give an alias for the whole module. So let's say, for example, again, import user functions as uf, for example, for an abbreviation. Now let's return back to the original names. You have to prepend them, of course, by the module name. So uf, or user functions dot create user, and uf dot authenticate. Let's test. Okay, it's working correctly. Finally, if you want to reference each and every function in a module file, sometimes we'll have modules that contain hundreds or thousands of functions. Sometimes you may need all of them, or you just don't want to bother keep preceding each and every function name used with the module name. So if you want to just refrain from having to enter the module name before the function name, you can just use from the module name user functions import asterisk for everything. I'm just telling you this because you're going to find this in the code that you're going to work with through your life as a DevOps developer or as a Python programmer. You're going to find code like this in modules and in README files and in documentation. Just want to make sure that you understand what this code is used for. Okay, so now I can go here and I can, of course, remove this uf, just create user and authenticate. Notice now that although I did not specifically tell Python that I want create user and authenticate to be present in my code, since I use the asterisk, Python is going to automatically explicitly import each and every function in this file, user functions, and now I can call them just by their names as if they have been created or defined in the same file, and I needn't also add any module name before the function name. So I can just use create name and authenticate. Let's clear and test. Okay, they work as expected. Okay, that completes our part of the course regarding Python. We have covered a lot of material about Python language. It's a very powerful language, can be used for lots of system administration and DevOps tasks. Although again, I have to remind you, this is not a comprehensive Python code. This is just scratching the surface. This is just a brief introduction to the language. In the coming part of the course, we are going to have a look at Ruby, which is also a very powerful scripting language. It is used in a few DevOps tools like Vagrant, Puppet, and Chef. So until the next part, take care.
The last part of this course is going to be covering the Ruby programming language. Ruby is a relatively new language compared to other languages like Python and Perl. However, it gained a lot of popularity in the last few years due to its ease of use and powerful features. Ruby is used in a lot of giant applications like, for example, GitHub and Twitter. We're going to cover just the basics, or let's say what you are going to use in DevOps tools that use Ruby like Chef, Puppet, and Vagrant. So we're going to cover just the basics, and let's start by installation.
Ruby does not typically ship with most Linux and Unix distributions, unlike Python. We previously said in the Python course or in the Python part that it ships automatically with Unix and Linux. However, this is not the case with Ruby. But it is fairly easy to be installed just using the package manager, whether it was yum for CentOS or apt-get install for Ubuntu. Let's have an example. We are here on our CentOS machine. You can just type sudo yum-y install Ruby, just like that. And in a matter of seconds, it is going to be installed on your system. If you are running on an Ubuntu machine, the same command is going to install it on your local machine. But of course, you will have to replace yum-y install with apt-get or the default package manager of your Linux distribution. Alright, once done, let's clear the screen. Let's ensure that Ruby is installed by writing a command like ruby ---- version, which is going to give you the version of Ruby that is installed on the system. It's Ruby 2.0.0, which, as usual, is not the latest release from Ruby. That is because, as we have mentioned before, the package manager of Ubuntu or CentOS does not necessarily grab the latest version of the software, because it will always lag behind a couple of versions or more so that they do their required testing and so on. So the cutting edge or the newest version of the software is not necessarily the one that you get through your package manager. If you do want to get the latest version and you are ready to put some effort into it, you can just go ahead to the Ruby website and download the source code and compile it on your system. However, I don't recommend personally this practice for a number of reasons. But if you are absolutely sure that you want the latest version for one of your projects or one of your applications, you can go ahead and compile it from source. You can go to Ruby website. Just let's open a new tab, download Ruby on Google, just like that. You are going to be you're going to navigate to the first result, which is ruby-lang.org, and you can choose. As you can see here, this is the latest version of Ruby. At the time of this recording, it's 2.5.1. You can grab a version like this one, compile it, and go to the instructions. It's pretty easy to compile Ruby. It's not a big deal. Or if you have another operating system like Windows, for example, or OS X machines, or a Mac OS machine, you can download Ruby installer for Windows, or you can use the brew. Let's go to our Mac here. Brew install Ruby is going to install the appropriate version for your system using the package manager, which is called Ruby. So you have a number of options when it comes to installation. Now, once you have it running on your system, you can just go ahead and create a file like this, ruby_essentials.rb. I personally prefer to work with script files. Some people will recommend that you start an interactive prompt like this one, IRB. It's called IRB in Ruby. And once you're inside, you can type in various Ruby commands and see the output in real time or in an interactive mode. But I personally prefer to work with the script files, because this is how you're going to run your scripts in real world examples. So I'd like the training or the labs to be as close enough to the production or to the real world examples as possible. Same thing holds, by the way, with Python. If you want to use the interactive Python interpreter, you can just type Python like this, and you will be inside the Python interpreter, this one, in which you can type commands like this, print hello. It will just give you instant output like this, okay? But again, I prefer working with a script like this one. So let's go ahead and type our shebang /usr/bin, and here is a cool trick. You can, if you don't know the location of the Ruby interpreter or of the interpreter that you're gonna use in general, you can just use the inv command /usr/bin/inv and give it the name of the interpreter, whether it was Ruby, Python, Perl, or whatever the binary that you want to use to run the code inside the script. This is going to have a look at your environment, and it's going to execute the command just like you did here. When I tapped Ruby, I didn't care to find where it does exist on my system, where its path is. If I did, I could just run a command like where is Ruby and find that Ruby is in /usr/bin/ruby. Sometimes if you compile this interpreter or this binary from source code, it might be present in a path like this, so /usr/local/bin/ruby, which of course does not exist, but you might find it there if you compiled Ruby from source. So in either way, this command will save you the hassle of searching for the appropriate path for the interpreter, just use usr bin env and then the name of the interpreter, and it will be automatically grabbed for you. Okay, let's have a quick example, and let's start with printing some text. If you want to print some text to the screen, you have to use the puts, or puts if you wish to call it, command or function, and just add the text like this: print hello world. Let's execute that. I'm gonna give the script file the execute permissions, and then /ruby, and you have hello world. Now, you will need to notice a very important thing here. I did not put any parentheses around hello world. Puts is a function, it is a method, and in a language like Python, I had to do something like this: print. If I were in Python, let's just add this Python code. I had to do something like this: print hello world in parentheses like this. If I omitted the parentheses, it's gonna give me an error. Okay, well, Ruby works in a slightly easier manner. It tries to be as friendly to the developer as possible. This is one of the slogans or the models of Ruby, which that it is a developer-friendly language. So it tries to be as simple as possible. It raises the slogan of there is more than one way to do a thing. So functions or methods in Ruby by default do accept not adding a parenthesis to their arguments. So this method is going to work equally if I opted to add the parenthesis like this: hello world. It's going to give me the same output. It is trying to mimic the bash. If you remember the bash course, bash would do something like this: echo hello world. It won't ask you to add any parentheses around the argument for the echo command. So Ruby tries to follow the same path by not requiring you to add parentheses to its functions or methods. Okay, so this is how you can print text to the screen. You can also use the print function. I can say print. Again, I don't need to add any parentheses. Hello world. But notice here a very interesting thing. Let's clear the screen and run the script again. Now I have hello world, the first one that was printed by the puts command or method, while the second one here, as you can see, is printed right before the prompt. Hello world, then the prompt. Okay, why is that? That's because print, by default, does not add a new line character at the end of the string. It lets you do that, and that is for extended flexibility. Because what, for example, if you want to type some text and you want to manually add a new line character, you can do this like that. \n, which stands for a new line character. Now, if you executed that script, you're going to find that both strings are printed and both of them have a new line character at the end. Okay, so that is a brief introduction to Ruby. In the coming lecture, we're going to see how we can use variables and how we can print variables interpolated inside strings. So until then, take care. All right, welcome back. Now, what if you want to add some string variables inside the string? Remember, in Python, we used to do something like this. For example, if I want to say my name is Ahmad, and by the way, this is how you define variables in Ruby, just the same as Python. Let's just delete those for the moment. Now I have a variable that is called my name that holds the value of Ahmad. What if I want to print put s my name is, and then the variable my name? In Python, I could do something like this: plus my name. But Ruby gives you a much easier way of doing this, much user-friendly way of doing this. It's called string interpolation, just by adding a hash symbol or a pound symbol followed by a pair of curly braces. You can add whatever expression you want inside this stanza or inside this code block. Like, for example, the variable that is called my name is going to automatically be substituted when I execute the script like this. So my name is Ahmad. But notice here that, again, Ruby follows the same path as Bash regarding string interpolation. In order to emphasize, if you replaced the double quotes that are surrounding the string with single quotes, you're going to see that it literally interprets what gets inside this pair of single quotes. My name is #, curly brace, my name, then the closing curly brace. It did not honor that this is a variable and that this has to be substituted for by the value inside the variable. It just interpreted it as literal # and literal curly brace. Okay, so we'll have to be very careful when using
single and double quotes in Ruby. This is, again, one of the differences between Ruby and Python. Python did not care whether you use double quotes or single quotes. Okay, the third method or the third function that can be used to print text to the screen is printf. And the difference between printf and print is that printf uses format strings. Let's have a quick example. We can just repeat what we just did. My name is, and instead of adding my variable in the pound sign followed by the pair of curly braces, I can do something like this. And this is if you are coming from a C language background, or if you have programmed in C or C++ in some stage of your career, you're gonna see that this is somewhat familiar. I'm adding here a placeholder for the string %s, then a comma, then the name. Let's just put a hash sign or a pound sign before those lines in order to comment them out. This is how you comment things in Ruby, by placing a pound sign before them. And if I clear the screen and execute the script again, I'm gonna see that my name is Ahmed. That is the same result that I obtained when using the putS command. So why printf might be of importance or significance? Well, consider the following example. I can say that we are learning, and I want to say 3 languages. We so far learned about Bash, Python, and now we are learning about Ruby. So I want to substitute this place in the string or in the statement with a number. If I added $d, this means that I am intending to add a digit here in this place. If I execute, of course, I'll have to add a new line character at the end so that it appears correctly. Okay, we are learning 3 languages. But again, what is the importance of this? I could just had 3 printed inside, or if this is a variable, I could use the string interpolation to print it. Well, consider now this somewhat different example. What if I said printf the pi constant is, and I'm not intending to add the exact value of the pi constant because I don't memorize it. Just give you an example. If I said %o.f for float and then the new line character, I can add here a long decimal number like this, assuming that this is the pi constant. Of course, this is not the pi constant, just giving you an example. But if I printed this, the screen is going to give me 3.15, which is the approximated value of this long number, this long decimal number, because I informed Ruby that this is going to be a float and that it's going to be a 2-digit float to the right. This means that it's going to approximate the second digit in the number to the nearest digit, so it's 3.15, and it's going to discard the rest of the number. So this is an easy way to quickly format strings or numbers using the printf function. And of course, printf has a lot of format strings. It can convert from, for example, hexadecimal to binary to decimal and so on, but I'm not gonna spend too much time into this. Just wanna inform you that it does exist and it is very useful when you want to format strings. Okay, now let's talk a little about quoting. We mentioned that in Python, quoting is not relevant. If you use single quotes or double quotes, it doesn't matter. But this gives you a flexibility. In Python, let's just mark this, that this is in Python code. Okay. You can do something like this. Print, for example, her pet's name is Kenzie, like this. Okay. Notice here how I'm using the apostrophe S inside the double quotes, and the code won't complain. That is because I'm quoting the whole string with double quotes. But what if I did something like this? Of course, this in Python doesn't matter. As we just said, single or double quotes don't matter. So double or single quotes won't matter. But in Ruby, they do matter. So what if in Ruby, let's say in Ruby code, and let's comment out this because this actually will print because this is a valid Ruby statement. I'm just giving you an example of Python code that we covered in the previous course. In Ruby, this is going to be different. If I need the string to be in single quotes for some reason or another, if I did something like this,
her pet's name is Kenzie. Notice now that this is gonna give me an error. If you try to run this code, I'm gonna get an error. That is because the code that I added here at the end is going to put all this string her pet as a string, and the rest of the string is just non-relevant for Ruby, or it will provide an error because this is not a statement. This is no longer part of the string, so this is not, and this is obviously not a valid Ruby statement, so it's going to give you an error. So the answer for this is that you are allowed to use quoting strings other than single and double quotes. Again, this is one of Ruby's strengths, which is that it gives you more than one way to solve a problem. So one way of solving it, before I forget, is to add a backslash like this. A backslash is going to escape whatever comes after it. So if I added a backslash before the single quote, it is gonna inform Ruby that this has to be interpreted literally as a single quote rather than the delimiter of the statement or of the string. So now if I try to run this code, it's gonna run correctly. Let's just add a new line character at the end so that we have the correct. And notice here how I'm escaping the new line character because I'm inside single quotes. Okay, it won't work. I'll have to add it in double quotes in order for this to work. Let's just use put s for this instead of print s and remove that new line character at the end. Okay, her pet's name is Kenzie. It is correctly printing out the statement. But I can also use another quoting mechanism, and this is very useful if, for example, you are invoking a shell script on Linux, for example, and shell scripts tend to have special characters like single quotes and double quotes and so on. So you will need to have a quoting character or a quoting mechanism that does not care about single or double characters. The answer is to use something like this: %, Q, then a pair of curly braces. Now you can add whatever text you want inside these pair of curly braces, and it's going to be printed exactly as they appear. So let's say here, pet's name is Kenzie, and she loves drawing. Notice how I added drawing here in double quotes, and I have a single quote here. And despite all that, the statement or the string is going to be printed to the screen the way I added it here. Literally just the way I wrote it inside the code. Her pet's name is Kenzie and she loves drawing. The quotes are preserved, the single and the double. I can even add a double quote here and it is work equally, and it's gonna work equally without complaining at all. So I guess by now you are starting to see the power of Ruby as a scripting language and how it is helping developers achieve their tasks in the easiest and the most efficient manner. In the coming lecture, we're going to start delving a little deeper inside Ruby. We're going to have a look at the arrays, how to loop through arrays. So until next lecture, take care. All right, welcome back. Arrays in Ruby are defined the same way they are defined in Python, but they are called arrays. They are called by their name here. In Python, they were called lists, if you remember. In Ruby, they are called arrays. So let's have an example. If you remember, we had a list or an array here, because we are talking Ruby, of usernames that contain, like, for example, Jado, Peter, let's make little changes, Mary, and Bob. Okay, those are 4 usernames inside an array. Now, the first thing you need to do with arrays, as you've probably guessed, is to loop through them in order to extract values, in order to work with the individual values and so on. In Python, you had the for in loop. So for example, u in usernames, and then you used to add a colon to start a code block, and then add blah 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 here, and then you return the indentation back to the start of the line so that you mark a code block as ended or as closed. In Ruby, things are different. You don't have indentation in Ruby, and you don't start the code block with a colon. Rather, you just go inside the loop, and you can, like, for example, put su, then end. Okay, end here on Ruby in general marks the end of a code block. I'm gonna talk more about blocks in Ruby later in this course. Let's just execute that code. Okay, guess I have a typo here. It's usernames. And as you can see, it printed the individual usernames that I had inside the array. But again, Ruby has more than one way of doing things, and especially in loops, you're gonna love the way Ruby handles loops. I can easily say usernames dot each. Okay, Ruby has a method that is called each that can be applied on any enumerable object. In other words, it can be applied on arrays or array-like objects. In our case, we have an array, so it's a perfect candidate for the each method. Now I can add do to start the block, and when I use do, I can add, or I usually in the each I add a variable inside a pair of pipe signs like this. You can add whatever variable you want, and this variable is going to be substituted for each of the individual values of the array. So let's just end, and inside the loop body I can say put su. This is going to give me the exact same result as the previous code, but notice here that it is more readable for the developer, more English-like syntax rather than the for in loop. Although the for in loop is still valid syntax, it will still work in Ruby. However, this, if you agree with me, is more readable for even somebody who hasn't used Ruby before or does not know anything about Ruby. Just reading the code is going to give him or her perfect sense about what this code is supposed to do. And indentation, again, is not mandatory in Ruby. If I just got this line to the end or to the start of the column and I write it and I execute it again, it's going to work exactly the same as before. And code blocks in Ruby has generally two forms. Either this form, which is do, and optionally adding a variable that is going to be substituted for inside the body of the loop, or you can do something like this, usernames.each, and then the code block is going to be just a pair of curly braces without do, without end. You can optionally again add the user like this, then put su. Let's clear, and if we commented out this code, it's going to give you exactly the same results as before. So what's the difference? Why you should use this or that? This is totally up to you, and this is totally by convention. Rubyists, who are people who work with Ruby a lot, they are called Rubyists. They're going to advise you that by convention, if you want to add more than one line of code in a code block, then it's recommended that you use this form, which is do, followed by an end to mark the start and the end of a code block. If you want to add just one line of code to a block, you are better off using this form, which is the pair of curly braces. Again, this is totally up to you. I can add more than one statement here. If I span this to multiple lines, it's gonna work perfectly as before. I can even add semicolons and add more than one statement on the same line, and it will work equally. It's totally up to you, but following the convention is always a good thing because it will make your code more readable, and it will make solving problems by other developers in the field much easier because you will all be following the same style of coding. Okay, we also have the while loop. Let's have a look. The while loop works like the while loop in any other language. Let's have a variable called y and set it to 0, and then start our loop while I is less than usernames dot, and if you want to get the length of the array, you can call the method that is called length. And notice here that each and every method in Ruby, I do not care to add a pair of parentheses at the end. Although it's perfectly legal to do so, Ruby won't complain, but it just follows the style of Bash. Bash does not generally have parentheses after function names. In Python and in other languages, you are obliged to add parentheses when you are calling a function, but in Ruby this is just an optional thing. So by convention, Ruby developers do not add parentheses after function names, so let's just follow the convention. And now back to our code. While I is less than usernames.length, put s or puts username, then, and again, if you want to call an individual item in an array, just use the pair of square brackets, the same way you do with Python. And this is going to give you the value of whatever index in the array at this point. So we're going to start with 0, so this is going to give you the first
item in the array. Remember, Ruby, like Python and like most other programming languages, have zero-based arrays, which means that the first item in the array is having the index of 0, second one is having the index of 1, and so on. So 0 is going to give me the first item in the array, but now I need to increment I, so I'm going to say I is I plus 1 just to increment the value of y and keep the loop running. Otherwise, it's going to just loop endlessly because y is never going to be even close to username's length. And finally, you add the end keyword marking the end of the array. And again, it's giving me the items of the array. So that is the for in loop and the while loop. But in Python, we did have something that is called range. And I'm intentionally making comparisons between Ruby and Python because I believe that is going to strengthen the concepts and the code snippets that you learned in the Python part of this course. And it's going to also avoid any confusion or any overlapping of concepts or of code between Python and Ruby. Just want to put both of them in front of you so that you don't get confused and you also remember what we covered previously in Python. Okay, back to our topic. In Python, we had something or a function that is called range. Range was used to give you a range of numbers from a starting number to the end number, not including the end or the upper bound. So if range 1 to 5 is going to give you 1, 2, 3, and 4. Ruby has a similar concept, and it does this in an even easier manner than Python. You can do something like this, and this is used, as we mentioned in Python, for loops that you require to repeat a specific number of times without having to abide to a list of objects or strings or numbers or whatever. You want just the loop to run for a specific number of times, and you don't want to bound it to any type of array or list. So I can say for I in, let's say 1, double dot, and 5. This is going to give me a range between 1 and 5. Then put s and say hello. This is going to repeat this statement or execute this statement. Let's see. Sorry, I forgot the in. It's for I in range 1 to 5. Now let's execute. Okay. And notice here it executed the statement 5 times, printing for me hello 5 times. So it's 1, 2, 3, 4, and 5. In contrast to Python, the upper bound or the ceiling, if you wish to call it, of the range is included in the execution. So if I have 1 to 5, this is going to be executed 5 times, not 4 times. And Ruby also has a number of functions that will make your life as a developer easier, and it's more like English readable, as I mentioned. So I can say, for example, instead of using this form for I in 1 to 5, if I want to type hello 5 times, I have another easier and more readable way of doing this. Just type 5 for an integer dot times the times function or method, calling it against 5, which is the integer or the number, do, then pass in the variable, which is the index of the iteration. Then let's do whatever I want. Put s hello there. And okay, now if I executed this, it's going to execute hello there 5 times, and I can optionally add the index number, which is n, inside the string. So as you can see, it's printing from 0 to 4 because I said 5 times. It starts at 0, ends at 4, and it's executing the statement or whatever I want to get executed 5 times inside this body, inside the body of the block. Okay, let's see another cool feature or another cool function of Ruby. I can say 0, and I can call the function up to and give it a number like 2, for example. So 0 up to 2 do. Now let's have the variable that is going to be substituted, and then let's say put s. And if we still have the usernames array, I can say usernames I. So I'm going to print the first 2 items of the array by using 0 up to 2. Let's clear the screen and run it. It's going to take the 0 index, so it's printed Jado, Peter, and Mary, because let's have a proof, and I can say
index I, then a colon. Okay. Now index 0, Jado, index 1, Peter, index 2, Mary. So again, it's starting at 0 and ending at the upper bound of the function, which is 2. So it printed the first 3, not the first 2, the first 3 items of the array, starting at 0 and ending at 2. And again, because parentheses are optional in Ruby, you can just write this in a very English manner, not syntax. It's not cryptic code. You can just write type 0 up to 2. So you can see it's very readable, it's very human readable, rather than the cryptic code that is used in programming languages like Java or C or even Python. This is very human readable. 0 up to 2, do, then whatever, put as then the statement that you want to print. Okay. Finally, you can also add something like this. Let's say if I want to print something in reverse, so I can say 3.down2, which is going to print everything in the array from the element having the index of 3, in other words, the 4th element in the array. Now I can say down to 1, which is going to print everything down to the 2nd element. I can say do I put s user names I and end. Okay, now you can see Bob, Mary, and Peter. It started from Bob, Mary, and Peter. It omitted the first or excluded the first item of the array because we started at the last item and we intentionally stopped at index number 1. Okay, so I believe by now you have a clearer idea about what Ruby is, how it is different than Python, how its code is very human readable, and how it could be so powerful, especially in simple tasks that should use less code. In the coming lecture, we are going to have a look at the other very popular data structure in Ruby, which is hashes. So until then, take care. Alright, welcome back. In Python, we used to have the concept of dictionaries. Dictionary is, if you remember, a set of key value pairs. You have a name and you have a value for that name that allows you to add some more detail about the item that you store in the array or the list. So there is the concept of dictionaries. In Ruby, the same concept exists, but of course with a different name. It's called hashes. A hash in Ruby is just a dictionary in Python. But again, because Ruby is so flexible, you have more than one way of defining a hash. I'm taking the easiest and the most used method here. Let's say that we want to define usernames again, but this time we're going to define it as a hash. Let's just comment out this one. And a hash in Ruby, same as dictionaries in Python, start or get defined using a curly brace, a pair of curly braces like this. Then you have, like for example, name, but instead of using a colon, like in Python, we use what's called a rocket assignment like this, which is an equal sign followed by a greater than sign. Let's say the username or the name is Jado, comma, and we have the age. Let's say the age is 31, for example, and finally the job, Jado is a DevOps engineer, okay, like this. Now, this is a hash. You can access any item of the hash just same way you did with Python by referring to it by its name, like this. So if I put as username's name, it's gonna give me Jado. Okay. However, Ruby has another way of defining the names or the keys of the values, and it is more memory efficient. And I'm gonna discuss in a moment how this is possible. Let's just take a copy of this before we comment it out. Okay, let's paste. And instead of adding the value inside a pair of double quotes or single quotes, in other words, instead of defining them as strings, you have the option of defining them as symbols. Symbols are something that are fairly unique to Ruby. They are not used in other languages, not that I am aware of. A symbol in Ruby looks like a string, but it is not a string. It is technically an object ID. So I can say name, age, and job. Okay, and this is gonna give me the exact same result as the previous code, except that of course I have to use the symbol when I call any value of the hash table or of the hash. So now I have JDO, same as before. But what is the technical difference between using strings and using symbols to define hashes, and why symbols are recommended by developers, or this is the most widely used method of defining hashes? That is because a symbol in Ruby gets defined in memory only once. So if you have multiple symbols in your code, they are only going to be defined once in memory. No new instances are going to be created. While if you created a string, each and every time you create a string in Ruby, a new memory location is going to be defined for that string, slowly consuming more and more memory. So using symbols in hashes will give you a slightly better performance and slightly more resource optimization, especially if you are using code that contains hundreds, maybe thousands of hashes, each having their own set of keys and values. So using symbols is recommended over using strings as keys for your values. Okay, you can do all sorts of things with hashes, just like the same we did with Python. You can add hashes to arrays, and you can make arrays of hashes. Let's have a quick example. Usernames equal, and again let's add them on one line just to have a clearer view, like this. Of course, you are gonna have to add a pair of square brackets so that you are defining an array rather than a hash. Now I can copy and paste those and change them quickly. Let's say Linda, Bob, Mark, for example. Let's change the ages. So now I have an array containing 4 different users. Each of them is having his or her own dictionary object or hash, technically speaking, because we are in Ruby now. So I can say usernames, and before referring to the name, I'll have to refer to the index of this username, since now I'm using an array. So now I'll have JDO again. If I refer to 1, I'm gonna be having Linda and so on. So I can say usernames.each do, and now u is going to be a hash object instead of just a string. So I can do everything I can do with the hash object with the u variable. So I can say print just the age of the user. If I'm only interested in ages, it's gonna give me the ages of the people inside the array. Of course, I can be more specific and add the name just to know which age belongs to which user. Of course, this requires that we use string interpolation. Perhaps you can add a colon here to be more readable. Okay, now we have the username followed by a colon followed by his or her age. This is how we can access hashes inside arrays. We can do the other way around. We can make a hash of arrays. Let's say, for example, we have 2 sets of languages. Let's say langs, programming languages, and we have a hash like this. Inside this hash, we have the name, and the name is, let's say, compiled languages. Then examples, for example, and this can be an array. So let's say C, C++, C#, and Java. Okay. Now, if I want to refer to C++, for example, I can say langs, have the examples, and refer to like the second item or the second element in the array of examples. Okay, let's add a comma here. And now we have C++. I can even be more creative and say put s examples with each do l example. Of course, let's remove this put s, and let's say language name is okay. So now you get the point. You can do all sorts of tricks with hashes and arrays, like putting arrays inside hashes, putting hashes inside arrays, and so on. Last in this part, you can also refer to keys only, or loop through keys only, or values only. Remember, in Python, we did something like this for k, v, in, and we have a dictionary, then dot items like this. Then you added a colon and you added the code that will loop through the keys and the values of the list. In Ruby, things are different, as usual. but you will have something similar. I believe it's simpler. If I want to loop through for L in langs do, then I can say put SL, for example, and it's gonna convert the whole hash to an array. Let's just omit the previous code or comment it out just to give you only this part of the code. Now I have name printed on its separate line, then the value compiled, then examples C, C++, C#, Java. Of course, this clearly is not the best way to loop through a hash table or a hash, because you might want to loop through the keys or the values or both. So if you want to loop through the keys, you're gonna do something like this: for key, for example, in and lang dot keys. This is a method, and put as k like this. This is gonna give me only the keys of the hash. If you want to loop through the values, which is, you're gonna just use values instead of keys, and it's gonna give you the values that are inside the hash. And if you want to, you can loop through both of them again. Since it gives you an array, you can just do something like this. Let this be I instead of k, because this is not a key. This is rather the item itself, so I can refer to the first item in the array, because again, this is gonna convert each and every item in the hash to an array. So these are the keys, and one will give you the values. You can do something like this: put s key is and value is, running code like this. It's gonna give me key is name, value is compiled, key is examples, and value is, and it's giving me another array of the values of examples. So as you can see, it's very easy to loop through hashes. You can restrict your loop to keys or values, or you can just use this notation or this method to get both the keys and the values of a hash table or a hash. Now in the next lecture, we are going to see something that is fairly unique to Ruby. It's not found in other languages, and those are code blocks. Code blocks are going to be seen extensively when using Vagrant and Chef and other DevOps tools that use Ruby. So I need you to understand the coming topic very thoroughly, because it's going to be used a lot. So until next lecture, take care. Code blocks is an integral part of Ruby, and it's used, as I mentioned in the previous lecture, extensively in software like Vagrant and Chef. So they have to be discussed in a little more detail. In order to discuss code blocks, we need first to discuss functions. Functions in Ruby are defined the same way they are defined in Python. They even use the same keywords, so they are fairly easy to understand. Just use def, then a function name like, for example, say hello, and optionally it can take an argument or a parameter like msg for message, for example, then put s message. Then you end the code block, and let's say hello, and again you are free to use parentheses like this. Good morning. This is gonna work. And if you want to use the bash style and remove the curly parentheses, this is going to work equally. There is no difference. Okay, so this is just how functions are defined. They're very easy. But sometimes you may want to add a generic piece of code inside a function. So let's say that you have a function that is very general. It does something that is common to one or more tasks, but you need to inject some external code to this function. This is where code blocks come into play. Let's say, for example, that you have a function that is going to greet the user of any of the applications that your code is going to start, or that the code is going to execute for the user. So let's call this function start app, okay? And start app is going to put as hello or welcome to the application, okay? Then some code should go here, then put as thank you for using our app, okay, for example, end. So this is a generic function. All what it does is that it prints a greeting, then some code is going to run, whatever that code was, then it puts or it displays a message, a thank you message for the user, thank you for using our app. Now what comes inside here, I need it to be injected dynamically. I need this function to be able to accept code and then run this code, provided that it adds the greeting and the thank you message before and after this code. How can I do that? Using code blocks. First thing I'm going to do is that I'm going to replace this comment with a keyword that's special to Ruby. It's called yield. Yield is going to be replaced at runtime with whatever code that comes in the code block that I'm going to define right now. Code blocks are defined by calling the function itself, which is start app, then start a code block the same way you did with nearly everything that we did in Ruby so far. A code block starts with do, ends with end. Inside it, you put whatever code you want to run inside this part of the function. Let's say put s, and let's say that this application grabs the current weather information or something. So let's say the current temperature is, let's say, 30 or whatever, okay? Notice that this code actually calls the function. I don't need to run start app like this now, because I'm already calling the function here and I'm passing to it some code inside a code block, okay? So this function is technically getting called with an argument that will get placed inside or in place of this keyword yield, okay? It's a little bit confusing at first, but believe me, it's easier than it looks. Remember in the previous example when we added here a message and we passed in this message to the function and it got displayed because we had put s message in here. This is nearly the same concept, but it's a little bit complicated, or it's a little bit flexible, which is that it does not accept a string, but rather it accepts a complete code block, a complete set of statements that could be anything. They could be a complete application, for example. Now let's execute this code. Okay, as you can see, welcome to the application, the greeting. The current temperature is 30 degrees Celsius. Thank you for using our app. This is the welcome and the thank you message. I can do all sorts of things with this. I can start app again, and I can inject another piece of code, like say the latest headline news are, let's say blah blah blah. Let's say that it grabbed the latest headline news from some news API, for example, and it's displaying it to the user, but we need the user to see the welcome message and the thank you message before and after whatever code comes. So we use the start app function in order to do this, and we inject our code inside. But notice that, as we mentioned before, we can use the shorthand for this since it's just one statement. So I can just use the curly braces instead of using do and end. It's more concise. Again, by convention, it is used whenever you are typing or injecting one line of code. You use this form of code block, the curly brace. If you have multiple lines of code, by convention, you should use this method, do and end. Let's run the app. Okay, welcome to the application. The latest headline news are blah, blah, blah. Thank you for using our app. Okay, what if you want to inject a code block that accepts arguments? Now, things are starting to get more complicated, but believe me, they are easier than how they look. Let's first delete this, and let's stick with this example. And let's say that we need to add something to the yield. We need to add a variable or a value to the yield statement, something that's going to be used inside the yield statement. Let's say that we want whatever comes in the news is preceded by breaking news, like this, followed by a colon or something, okay, and a space. Now I want this text to be injected inside the yield statement. So I can add, and like I did with something like the each method before, I can use a variable inside like s. S is going to take whatever here in the breaking news, whatever comes here is going to be substituted with here instead of this variable, instead of s, and then I can add put or puts. Then I can add s, and I go ahead with my code. Now, breaking news, latest headline news are blah blah blah. Here the function is not only putting a welcome message and a thank you message before and after the code, it is also injecting some code inside whatever code block it's going to accept. Like it's putting its own rules, it's drawing its own rules. It's like it's telling the code block, if you want to run, you can make use of this string as well inside whatever you're executing. Of course, this is optional. If you don't want to use S, you are free not to use it. It's just a way of injecting a variable or injecting some value inside your code block. So if I omitted the variable, or I didn't, or I just or I just discarded it, things are gonna work the same as before. The latest headline news are blah blah blah. Nothing has changed. Okay, so that is briefly how you use code blocks. You're gonna see later in this course or in this program, when we study something like Vagrant, you're gonna see that it uses code blocks extensively in its configuration or in its instructions files. So for example, you're gonna see that we have a configuration file that starts a machine, and then inside the configuration, you're gonna see something like vagrant.config, like this. And then you add a variable like d, for example, and then do, and then end. So when you see code like this, I want you to remember what we studied here in this part of the course about code blocks, and that all what this does is that it is injecting some code inside a function that is called config, that is part of the Vagrant code. It's just a way of injecting code from the user to the function. Okay, this is how code blocks work, and this is why code blocks are very efficient and very widely used in Ruby. Again, a way of injecting external code to a function that accepts that code, and it has some way to process that code inside it. Like we did here, we are injecting this code, the latest headline news or blah blah blah, inside a function that adds a greeting at the start and a thank you message at the end. And of course, don't forget to add a variable if the application needs to. That brings us to the end of this lecture. In the coming lecture, we're gonna cover the final part of this Ruby mini course, which is how to use modules. So until then, take care.